Well, hey, everybody, welcome to the webinar. Welcome back to Compost Academy. I know it's been a minute. We haven't done a webinar in a hot minute, but it's so great seeing everybody coming on back as we've been doing so much in the background. We've been filming, we've been making case studies, in case you've been composting. Brian's been working on vineyards and consulting. So we have so much to share that we've been up to. And that's one big thing we're sharing in this webinar is today's webinar is about regenerating living systems, especially in urban landscapes. A lot of us are coming in from landscapes. It's not just the farm. It's not just the vineyard. We need to learn how to understand our urban landscapes because that's some of the biggest crops around. How do you manage enormous contracts over, acreages across cities, parks? How do you regenerate trees that are very high value in these urban landscapes? These are just some of the topics we're going to touch on today. But I'm going to hand this over to Brian Vag, and we're going to get started because we've got a really exciting webinar today. So why
Awesome.
don't you
Thank you,
take it
Raleigh.
over, Brian, and let's get going.
And just to check, you guys can see what I'm sharing? Okay.
Yeah, everybody type in there, let us know.
Perfect. All right. It's coming out good. Yeah. So, as Raleigh mentioned, we're going to be talking about the living landscape today. And really, it's going to be focused on the urban landscape kind of area. And before I start, I just kind of want to, talk about that. Early in my career, I was really hyper focused on agriculture and, small to large scale kind of farms. And I had a number of clients that were, some of the residential kind of homestead type of thing. But I didn't really have a lot of experience with urban landscapes. And my client, Tony, came to me and said, "Hey, look, I'm, one of the largest landholders in Southern California with commercial and retail properties. And we have challenges in our urban landscapes." And it was, quite an interesting thing to say, "Oh, well, what we do, can we fit this into that whole model of doing urban landscapes and making big changes?" And we talked about it and said, yeah, the principles that we use apply both in from agriculture to ecosystem restoration to urban landscapes, but let's fit and just, create a model that's going to work well for the urban landscape kind of environment. And I was very fortunate to have a client like Tony to say, "Hey, look, let's you and I figure this out together and actually, pull this into a practice that we can then start to transform large acreage of landscape environments." And then really when we started to dive down in this, and Tony already has a lot of experience because he does that, but for me, I had to learn a lot about what are the challenges. And there are some commonalities from like agriculture and ecosystem restoration, but there's also some very unique differences that the urban landscape environment has to deal with. And so for me, this was a lot of a learning process. I had to cut my teeth and understand what some of those challenges were to be able then to fit what our practices were going to be successful in this space. So, with that being said, let's kind of start with defining, this problem statement when it comes to, urban landscapes. And, my opinion is this, that a lot of the urban landscapes are really managed in a way that do not really strive for soil health. Which really then has this kind of cascading set of conditions where the irrigation demands get increased. And we're using potable water, which is a crazy thing. There's a lot of money that's spent on making water potable, and then it turns around and being used in our landscape environment. So there's an expense to that. And then with this, because we're not managing our plants in a kind of a soil health paradigm, there's a lot of challenges with the plants that they are not resilient for the long haul, that they are susceptible to diseases and pests and so forth. And what this really kind of leads us down a road to is that there's long-term ecological and also economic problems with maintaining a lot of these urban landscapes. So I went on to try to find, some data that really talked about, what does this challenge look like? And I know right now this is a U.S. perspective as far as these data points, but really this is a worldwide problem. When we look at urban landscapes, they do use a tremendous amount of water. In fact, by the EPA standards, nearly 1/3 of residential water is used for landscaping, and that's 8 to 9 billion gallons per day. It's in a crazy amount of, and this is potable water. So it's not always potable water, but a lot of potable water is used. And that what that means is that it's been treated. It has gone through that expensive process to make water drinkable, but then it's also now being used in these landscaping environments. And then really kind of peeling the layer of the onion farther down, about 50% of that irrigation water is lost to runoff, evaporation, and the water's not infiltrating the soil very well because of compaction, because there's not a lot of structure, because the soil health is not actually what it should be. And this is a hugely inefficient system. So there's a lot of water loss that's being just gone up into evaporation or just run off into the water stream. And then, so this poor soil structure that we have is really causing us problems in the long haul to be able to have healthy plant ecosystems in our landscaping environment. And there's one thing that I think a lot of the regulators and a lot of people in the industry look to is say, all right, well, we probably have inefficiencies in our irrigation, so we should look at irrigation technology. And so now there's all these smart controllers that will adjust with their irrigation depending upon the climate issues, monitoring soil moisture and things like that. And I will say those are fantastic technologies, and yes, we should be applying those, but it's bigger than that. It's really the irrigation technology is not going to solve the problem. In fact, it's not really the problem itself. It's soil function is the issue. So if we're able to restore soil biology and really get good soil health, now we're in a paradigm where we can reduce water consumption. The plants are more resilient. We get a much better ecosystem that evolves because we're now focused on soil health, not just on how do we make irrigation controllers better in that sense. All right. So, in today's presentation, we're going to talk about really two projects. And these are projects I've worked with my client down in Southern California. And the first one is around a property, Alton Retail. We decided to choose this as our test plot. This is where we were going to start to determine if we could reduce water by focusing on soil health. And then, really, as part of this, though, we have to be sure that we maintain plant vigor and aesthetics. Aesthetics is one of these kind of highly subjective things, but when you talk about the landscaping environment, that's the metric that people are looking for. If the plants look healthy, if they're flowering, they look nice, that's what we're looking for. Like, and when we're in agriculture, aesthetics is really way far on the down the list. In fact, in a lot of cases, not even represented. It's more about production and what kind of produce are we pulling off the land. So it's a different mindset when it comes to what we're trying to achieve in an urban landscape environment. So that was our first project, was the Alton Retail. The second project is looking at olive tree remediation. So, olive trees are a very common tree species that's used in landscaping down, especially down in Southern California. And there is a challenge. There's a lot of olive trees that are in decline with diseases and pest problems. And really, the vigor and the aesthetic value is just not there. So we're looking at, well, can we apply some of those same principles that we learned in Alton Retail to olive tree remediation? And this is an actual project that's in progress right now. All right, so let's talk about Alton Retail. So it's kind of the typical strip mall. It's going to have a number of stores that are part of this. There's a parking lot. There's areas for eatery outside, and then there's landscaping that fills in all the gaps. And really, from my client's perspective, it was, these spaces are meant to be pleasing so that people, when they go to these stores or these shops, they feel this kind of natural vibe. And in fact, that's a very powerful thing that comes from my client and his company in particular, which is that's a standard that they put, is that they want to have highly aesthetic landscapes that really attract people, that people want to go there, that they feel at ease. And so this was our test center. And so this project was 2 years in length. So we were going to apply our practices, and we were going to have a treatment plots and control plots so that we could actually measure the differences between these two environments, how we were treating the landscapes within this retail space. And we didn't plant new landscape, so this was an existing landscape environment. So we needed to continue to maintain the plants that were there. And the ultimate goal here for us was to determine, can we reduce water? And if when we do reduce water, what is the impact to the plant community? Do we still have plant vigor? Do we still have the aesthetic value of those plants? All right. So, what did we do in this project? So, over those 2 year period of time frame, we did apply compost, and that was one time per year. And this is the physical form of compost. So, we would pull back the mulch, we would lay a layer of compost into the environment. We put back the mulch, and there we go. And then we also applied compost extracts. And so, for those of you that aren't familiar with a compost extract, it's simply washing the biology off the surfaces of the compost so that now we have the microorganisms in the liquid, as well as humic acids and some soluble nutrients. And we're going to apply that in a liquid form, typically in the form of a soil drench. And that's what we did at this particular property. And we applied these compost extracts quarterly, and we did a total of 8 applications over the life of the study. And then we did soil sampling. So we sampled every time that we applied an extract, we waited 10 days, and then we pulled the soil samples to then evaluate what were the changes that we were observing from a soil health perspective. And then we also, from the irrigation side of the house, we reduced our irrigation by a percentage. And again, these are the smart controllers that were being used, where they adjust for the amount of the climatic conditions. So the hotter the days are, the drier or the less relative humidity in the air, the more irrigation gets applied. And then when we have rain events or other high humidity events, then we reduce that amount of irrigation that's going to go out. And what we decided is then to make a percentage difference between the control plots and the treatment plots. And I'll go through that in just a minute when we kind of look at our irrigation timeline. And the valves were locked down, which means that nobody could go in there and really mess with them as far as, oh, I decided I'm going to add more water here or to these different plants. We wanted to keep the environment as pristine from making sure that the variables in our test didn't get blown away because somebody went in there and inadvertently decided to water something when that they shouldn't have. All right, now compost. This is something that was really a driver. And when we talk about our practices, when we look at focusing on soil health, one of our primary tools is compost. And we use two different forms of compost in this. And Keisha's going to talk about that compost because Catalyst Bioamendments had a huge impact into the other vendors' compost that we use from TVI. So, Keisha, I'm going to go ahead and hand this over to you now.
Hi, nice. Go ahead and yeah, thank you. First of all, you guys, I can't believe there's 79 people in the room. I feel like we didn't get around to advertising until the day. And it's like really validating that you're all here. And I want to thank you for your time. I think it's really cool that you're joining us. Um, I'm going to just introduce Catalyst a little bit because I realize most of you guys I recognize, but some of you I don't. And so this whole craft compost, that's what we call our brand, inoculation grade compost. Brian just actually did a talk at the US Compost Conference, and I didn't get to be there, but he was using these words, inoculum grade compost, when he was giving this exact presentation. And so many people were like, what? Like, what is that? I've never heard that. Like, it seems important. So this is why I wanted to interject a few slides here. Catalyst, we are all students of Dr. Elaine, who we have recently lost. I know like you guys are probably all feeling it as much as we are. But she was a mentor and she was the one that pushed us into making Catalyst bioamendments. Anyone that knew her very well, this was her mission. We need to have people growing microbes and compost piles all over the world. So, of course, when Dr. Elaine tells you to do something, you jump on board. And we needed a name. We needed something to describe ourselves that wasn't compost. It can get real confusing when we talk about compost and inoculum grade compost. And we were actually on our way to an Alan Parsons Project show with all of the Sierra Soil Biology Association people. We were going out for just to have a good weekend. And we were in the car and we were trying to think, she's like, I'm trying to trademark this term called biocomplete. We need to come up with something really similar. And so we were going through all of these different words and we came up with bioamendment, a biological amendment, right? A compost that you can add to a soil, another compost pile, some sort of organic material or food, and it's going to already have all those organisms in place that are going to thrive. So really challenging trying to find out how to describe what we do. I wanted to start out first by showing you guys the actual microbes. So Casey and I have been at this for, oh, 7 or 8 years. I get lost on numbers sometimes, but for quite a while, we have been trying to create this product that is consistent and available for people all over the US to use as an inoculation for their compost pile, for their soil, or really whatever they need, teas and extracts like Brian's talking about. Um, these are not actual photos from my compost. Some of these are old growth soil. So I just wanted to give you a picture of who it is that we're trying to support, whether in our compost pile or in the soil. Brian, next slide. So what's different between a bioamendment and a typical compost that you're going to buy at the store? For me, I think for a lot of years, I would talk about the microbes just endlessly, and most people don't understand microorganisms. It goes right over their head. And it was actually just recently that I realized what really differentiates us from a lot of other people in the business is our processes, and it's a lot easier to explain it from a process-based reality. So I'll start out like when we talk about microbiology first, we're talking about like from the base of our processes. So you'll see in this photo our compost lot. That's the number one thing that we focus on to make sure that our aerobic microbes are happy. When you look in this picture, you won't see any plants. You see nice flat ground. There's no holes, there's no puddles, there's no manure or organic materials just rotting in the water. It's clean. When the water sheds off our compost pile, it's going to come right off the pad and it's not going to create erosion. It's not going to carry any sort of nitrogen into the surrounding rivers. It's going to stay right where it's at. Most compost companies at scale do not care for their pad like this because it's extraordinarily expensive. I won't be exhaustive on this. I'll move. Windrow turners. This is another piece of machinery that a lot of compost producers don't use at scale. There's many ways to decompose organic materials, and you can use a huge loader, but a windrow turner is very effective at getting the inside of the windrow to the outside of the windrow. This is like the basic idea of what we're always trying to do is get all parts of our compost pile into the hot center. So next thing, high quality inputs. This is where we lose a lot of people because Catalyst is a little bit crazy. It is our stated mission to be here for our clients to make sure that our compost is always at the highest peak of biological activity as we can, manage. So we go kind of crazy with our inputs. Everything that we use is either purchased, grown ourselves, or hand collected and brought in. There's no waste that's dumped at our site. I want to just stop for a second and let you know, you don't have to be as crazy as us to grow beautiful compost that is just as good, if not better than ours. The reason that we go with high quality inputs that we purchase is just to make sure that our clients get the product that they're looking for, right? So at Compost Academy, we explore all kinds of different things. You're not expected to buy grains, which we do. And you see that in the picture. You've probably never seen a windrow like this that's in its hot stage and growing plants. This is part of our operating procedures that we adapted over the years that we really like. We can talk more about that later in Q&A if you guys like. But I want to move on. Next thing, kind of unexpected. You would think anyone working at a compost facility would be highly skilled in what they're doing, but the truth is in these large facilities, they have a high turnover rate. It's quite rare to find a facility that really wants to educate their operators. And I don't want you to make you think we have this huge team of people that are so highly educated, but I will state every single person that has ever been hired with us, that's ever worked with us, we've paid for them to go to the Soil Food Web School. We've educated them ourselves. We've stuck with them for every minute to make sure that they understand all of our processes. So everyone that works with us are like, they're highly elevated. Like they know what they're doing with organic materials. And in some cases, I think they might even be better than me at moisture management and understanding the proper textures of compost. Yeah, it's crazy. Anyway, it's very, very rare to find large scale facilities that do that. The other thing is data-driven recipes. And this is kind of what I always went to, my go-to in describing what we do. Well, we use data to look at our microbes and drive all of our processes. And that doesn't really make a lot of sense unless you get specific. So I'll do that. There's a few things, lots of things we changed, but there's two really big ones. One being lower temperatures. So every single time we make a compost pile, a windrow, we're documenting everything that goes in, the moisture, the amount of water, the time of year, everything that we can consider. Now, if we see a pile that looks really extraordinary, the ecosystem is just bam, it's apparent, it's there, it looks beautiful. We're going to go back to our notes and say, hey, why is it that this ecosystem is in place so quickly? Why is it so robust? Can we track and understand? And one of the things we noticed is lower temperatures actually produce a much more vibrant microbial community. Now, when we got started, our training, it was kind of like temperature is the goal, heat is the goal. And so that's what we were focusing on was getting that pile hot fast and maintaining it, right? Well, we've learned now to adjust our recipes to stay within the strict laws of California. We have to turn a certain amount of time within a certain number of days, but to also respect our microbial population. So all of our recipes now are geared towards lower temperatures. Next thing would be soil structure, compost structure. We don't just track the microbes as we're building the pile, as it's heated up and as it's cooling off. We track it the entire time we have it. So some of these windrows we've had for upwards of 2.5 years, and we follow the biological activity, and we started noticing, dang, some of these piles are crashing out soon. We're not able to sell them anymore. What's going on with our ecosystem? Well, guess what? We realized it was those chunky chips. We have to have structure in the pile. The microbes will be there, but they can't persist. They can't continue to grow and expand unless they have that structure. So those are two really big things that we've changed in our processes looking at data over the last few years. Next thing you'll see are compost covers. They're expensive, they're heavy, they're hard to put on. Most companies don't use them. A lot of composters don't. For us, in one way, if our piles get too wet, we can't sell it. So it just makes sure it makes sense to protect it. But the reality is the piles have to keep their moisture in order for the microbes to continue reproducing. So if there's one thing that we harp on over and over and over again, it's moisture in your compost pile. If you guys know me, you already know. I'm sure I'll get some funny comments on the side. Um, Next thing, sifting. I'm just grumpy about sifting. I literally do not want anyone to sift their compost unless they're using it tomorrow. And I tell you, it loses us a lot of money because people will call and they want us to sift the compost, ship it out bulk, and they're going to use it over a year. And I just won't do it because I feel like I'm just nervous the microbial communities will collapse and then it'll come back on us. So, like we talked about with the wood chips in the bag, I prefer that people sift their own compost or promise me that they're going to use it right away. Next thing is bagging to order. I think we're all freaked out about putting microbes in plastic. If you order from us, absolutely every single time you're going to get it fresh. Um, but I've learned from distributors that it's not necessarily the bag that's killing these microbes as it sits on the shelf. They probably were never there in the beginning. Although I'm a little bit crazy and I don't like it to sit in the bag, they've proven me wrong by holding bags for extended periods of time and then asking me to put it under the scope. So these microbes are pretty hardy, even if they're in an awkward position. But so let's talk about this. When Brian was doing this study, they used our compost, the Catalyst Bioamendments craft compost, as the inoculation for their teas and for their extracts. That's pretty common use of our product. But when Catalyst got started, our ultimate goal, like we wanted to be a composter for other composters. So in our minds, this might be like we're kind of full of ourselves early on, but in our minds, like we could sell a couple yards of compost to the large scale facilities, and perhaps that would improve their product. So Brian, will you? Man, these guys just like literally life goal accomplished. So, so cool to work with these guys at TVI. Obviously, our compost is $750 a yard. You don't want to ship that a long distance to use as your bulk amendment to put on the soil. But it is true that the compost that you put down on your soil should be, it's going to be best if it already has an ecosystem in place. So the idea here was that we use our compost to inoculate this very large scale compost. And I can't even tell you how many yards or tons are in place. I think that's a 5 acre block that you're looking at of compost right there. This photo was taken probably 6 months after they started working with our product. And I'll tell you, it was 2 yards of our bioamendment that went in to make that compost. They apply it with a big spray truck. They basically just drive up and down those windrows and they just shoot compost extract and water the windrows with it. Instead of watering with actual water, they were watering with our extract. Now, They did have to shift some of their practices. And this is where we often, I was saying earlier, often it's hard to work with these large scale guys because there's so much difference in what we do and they do that costs extra money that it was just like impossible for them to even begin starting. At TVI, not the case. They were already set up. So they decided that they were happy to adjust some practices, not all of them. We're still working on it. Um, but they were happy to accept the cost. So when you're doing a trial like this, before you set your practices in, it's much more expensive. You have to buy new equipment, you're paying for data analysis, you're training people to do new things, and they were really happy to take on that cost. Now, I'm grateful that they did it, and I'll just tell a quick story. The guy that actually runs this facility didn't believe in any of this. He was actually kind of like scoffing at it. Lots of people come to him with products that they say, spray this on your compost, it's going to make it so much better. And he kind of laughed, but the guy that we're doing business with, it's his best friend. So they decided to go ahead and go through. He bought our compost, he extracted it, he put it on the windrows. I'm not sure how long it was before he walked out to check them, a few days, a week. I really don't know. But he said when he walked out, he was like, I noticed right away that the color changed. And you can tell by the way he's talking, he's just shocked. He's like, it was darker in color. He's like, and then I noticed that smell. And their compost doesn't stink, but it's got this high note of like sour, I would describe it as. You can smell it from pretty far away. He's like, you couldn't smell that sour smell. He's like, when I put it up to my nose, it smelled like a forest floor. He's like, and all of a sudden I was like, man, there might be something to this microbe stuff, which I think it's funny, but I also thought it was incredible that so quickly he was able to notice something texturally with his eyes, with his nose, that actually just like launched him into doing this like full time for the project. So I do want to point out why it is that he was able to transition so easily. A lot of folks hear this story and then they go, oh, I'll buy Catalyst Bioamendments and I'll spray it on my local compost and it'll be great. That's not always a fact. You want your compost to go, you want your microbes to go into something, a healthy environment for them. So the fact that these guys already have skilled operators, a lot of these guys, their operators have been working there for 30 plus years. They're highly paid, they're well respected. The guys on this team, they all talk good about each other. They're best friends. It's a huge team of awesome composters, and they were ready to do something new. They were a little bored, I think. Next is their pads. This is an old military base, so it's like, yeah, everything's at grade. You can see there's no puddles anywhere, no anaerobic conditions being formed passively. The other thing is they have a really good relationship with their haulers, just like they do with their employees. And so the haulers were absolutely willing to like play along, do our crazy stuff, separate certain inputs. So, without that, it's almost impossible. And the next thing is just that they had open minds, which I already said, but the fact that he saw a change and really thought like, okay, this might be worthwhile, that really made this possible for us. And I'll also say on a side note, this has nothing to do with this study, but look at all that compost. They had a whole bunch of it. They weren't selling it. So he donated to a lot of farms and he was like, oh, the farmers were like, this stuff really works. And he got stoked out just by the idea that like he could give this compost away and suddenly his product was looked at as this real game changer for farmers. So this has been just such an awesome transition and experience for all of us. And again, thanks for coming and listening to our story. Brian, get back into the data.
Sure, no problem. And yeah, I just a couple points I want to add to this because as part of this, my perspective from the story is when Tony came to me and we started talking about this project. One of the things that we identified right off the bat was down in Southern California, there was not a good source for beneficial soil microbes in the compost that we were able to get. And this is where my client Tony came into play and said, "Hey, look, I work heavily with this composter. I think he's willing to make some changes." And that's how this whole circle came about, right? Getting catalyst down there, getting the microbes onto the piles, and it was because of that change. It's simply a grower producer went to the compost manufacturer, said, "Hey, we want to make a change." They're willing to do so. And now we have a form of bulk compost that we can use effectively, that the microbial value of that compost went from a low floor to kind of a mid grade, which is a huge step in the commercial composting world. That is not a trivial thing. And I'll say when I went to the site to see it, you could tell the differences right off the bat from the biological rows to the conventional rows that they had. I mean, just from the smell alone, the texture of it was the most impressive. That was one thing I think Darren at TVI was like, wow, yeah, you can feel it. It's sticky. It's got the what we typically look for in a very biological compost, where in the other products that wasn't there. And then the color changes too were just amazing. So it was one of those kind of kismet things, being able to pull enough people together to say, hey, let's make a change. And it took an ecosystem of people to kind of make this change happen. So, all right.
I'll add that it actually
Yeah.
looks like our compost. Like if I
It's
were to grab some of our compost
right.
and ship it to someone, they'd think it was the same. It it's just less microbes. It's
Yeah.
it's
Right.
interesting.
Right. All right, so let's talk a little bit more about the Alton Retail project. So compost extract was another tool that we used, and again, we used soil drenches where we would apply in this one retail space about 750 gallons of compost extract in our treatment plots. Again, we did that 4 times a year. Now, what were we testing? And this actually, I give huge kudos to Tony because, he really wanted to be able to collect enough data so that when he went to his executive team and said, this is the changes that I want to make, that he had, data and proof to kind of stand behind, and in order to make changes. And we're talking, this is a very large company that owns a lot of acreage in Southern California, millions and millions and millions of dollars worth of landscaping. So making a change in their environment, they are going to want to make sure that whatever change they're going to make has already been proved out, that it's going to work, right? So Tony said, like, look, let's kind of put together what we need to be able to make this proof point. So we looked at soil organic matter, soil respiration, and all the soil chemistry analysis. We looked at the nutrition, the NPS, and the different cations that are going to be for plant growth. We looked at the soil water holding capacity. So we looked at water stable aggregates that were in the soil. And then we looked at soil biology. So we did microbial assessments. This is through the microscope, where we looked at fungi, bacteria, protozoa, and nematodes. We did DNA analysis so that we could see how the diversity and the speciation changed over time. And then we also looked at the soil enzymes. How did that change the kind of available amount of soil enzymes the microbes were helping in the plant community? And I want to say, this is not a typical thing. When we are talking with clients, usually the amount of money that's for testing is usually really, really teeny. We can do maybe a few tests and then we're trying to fill in the blanks. In this particular test, no, we spent a good amount of money on doing testing to make sure that we had the proof points available to us. All right, so let's start talking about the data. But before we get in there, let's look at this map because this is going to be an important story for us as we kind of go through this. The areas in green are the treatment. So we had a treatment turf area, we had the treatment camphor area, and then we had palms that were kind of in these cutouts in the sidewalk. And then we had an area with pines and a kind of understory planting. And then we had our controls, same thing, control turf, control camphor, control palms, and control pines. And you notice that there is separation. So when we look at this, what's very interesting is that, there's parking lots, there's buildings, there is areas of separation between the treatment and the control. And this is foreshadowing because this is going to be an important point as we get later into the data. All right, so let's take a look at the soil biology. So this is where we did a microbial assessment and we looked at those 4 categories, the bacteria, fungi, the F to B ratio. So that means how much fungal biomass to bacterial biomass. And this ratio is important to us because we know that in early successional growing systems, they're much more bacterially dominant. When we get to more established, mature, like tree type ecosystems, they're going to be much more fungally dominant. So we want, because this is mostly trees and shrubs that we're talking about, we wanted to push more into the fungal dominance than the bacterial dominance. All right, so when we look at the bacteria, we saw a decrease in bacteria in the treatment and the control, in which this was expected because, again, highly bacterial dominant environments, the soils were really poor, weren't structured very well, and the microbial community was pretty low. and mostly bacteria. Bacteria was the large dominant biomass that was in those soils. So seeing a decrease in bacteria was what we wanted to see, and seeing it was a good thing. Next was looking at the fungi. Well, we saw a 250% increase from over the 2-year period in our fungal biomass, which is a huge amount. That is a great movement of the fungal community into the space. But the control moved by 200%. And that really made us scratch our heads significantly. We're like, why is the control moving so much different? Because we didn't change anything with the control. Well, let's talk about F to B ratio. We saw that it went from a 0.4 to a 1.8. So we went from a bacterial dominant soil to a now more fungally dominant soil in our treatment blocks. But we also saw the same thing in our control blocks. They went from a 0.2 to a 1.3 in the control. Okay, again, we're scratching our heads. And then we looked at the protozoa. So the protozoa increased 840%. I mean, we went from an environment that had very low protozoa in the baseline before we started this. And by adding the compost and the compost extracts, we were adding good sources of the different protozoa. So flagellates and amoeba and ciliates and so forth were getting into the soil. But then we also saw not as much of an increase, but still a pretty significant increase in the control plots, 85% in the control plots. And, when we got at the end of the study and we really sunk into this data, we were scratching our heads going, what is going on? And the DNA test analysis really helped us kind of unlock what we think was going on. So when we looked at the DNA analysis, we saw that from our baseline, this is before we started doing any treatments, there was a amount of species of bacteria and fungi that exist in the soil, both in the treatment and the control. When we started adding in our treatment products, the compost extracts and the compost to our treatment plots, the speciation changed significantly. We saw a massive increase in diversity of bacteria and fungi and protozoa and nematodes, right? So we knew the compost was driving or delivering us these microbes. But when we looked at the DNA from the control plots, we saw the same species. The bacterial and fungal populations just leapt right over. And this was kind of that transitory aspect of microbes. They're not stationary. It wasn't like a bacteria just decided to move over from the treatment plot to the control plot. It is they taxicabbed on animals. So there's plenty of birds and insects and reptiles that move all throughout there. But humans are constantly, when you go into a retail spot, how often do you see people walk through the actual landscape? Like, I'm going to take a shortcut. I'm going to walk through here. I'm going to go through this area. And then all the people who are maintaining those landscapes, they're constantly walking on them as well. And it was this movement of microbes from the treatment to the control plots. The one, I guess one thing that we probably didn't have well in our design is that we didn't have enough separation. We probably should have chose 2 retail centers that were miles apart and then actually looked at it knowing that we could really reduce that transference. But it did give us some insight that how transitory in nature these microbes actually are. Given the chance that once they're now present to be able to move into these environments, they can. But it still didn't move into the degree in the control plots that did in the treatment, because again, the treatment, we were adding so much of that biology. So it was still very valuable for us to look at those treatment plots and say what we did actually had some significant impact.
Brian, can I jump in just really quick?
Sure. Yeah.
This is like this part of the data I just typed in. It was so exciting, the DNA, but this part of the data, like Brian says, we don't get this kind of funding to work with. Like he said multi-million. I believe it's multi-billion. Like these guys have
Sure.
flow and they were willing to put a lot of it in. And it's so cool for me because like I've been my whole entire career just constantly spouting off about how important it is, even in our own yards, our own tiny little space, to work on these microorganisms. And why? Because it preserves them in that space and then sends them out to all of our neighbors and all the area around us. By being a harbor for these diverse organisms, we're actually impacting everyone around us. And for a long time, I was just saying that because it's what I believed in. It
Right.
just made sense. But when the study was over and we got this data back, I was like, man, transference is real. And you can look like there's a percentage of like how quickly it happens. So for me, this is just like, ah,
Yeah.
I just wanted to put that in case you didn't catch.
Oh yeah, believe me, this was like a dream type of situation for us, and I am extraordinarily appreciative of the commitment that Tony put into this, and the money and resources that he put into doing this as well, because this is data that was concrete enough, right, to be able to go through. And we pulled in another company to help us do all of the chemistry, soil respiration, DNA analysis, and so forth. And so there was multiple teams of people collecting this data to be able then to come to these conclusions. Now, when we look at the irrigation reduction, so this was our premise, was as we started in our treatment plots, we were going to reduce the percentage of water to our treatment plots to see if those plants were able to still maintain their vigor and aesthetics, and that we didn't have challenges or problems with that. So in June 2022 is when we first did our pre-treatment sampling. So this is all the baselining. This is where we collected our baseline DNA, baseline soil chemistry, and microbial assessments and so forth. In July 2022, we added our first compost application. And then by November 2022, so about 4 or 5 months later, we did a 15% reduction in irrigation on the treatment side of the house. Control still maintained what they had before. The treatment was 15% less. And then in June of 2023, this was our second physical form of compost application. And realize we've been doing extracts along this timeline as well. And then by August 2023, we decided let's take another big leap and let's reduce the irrigation by 30%. Now, when we did that reduction, and this again is the middle of summer time frame, hot, dry, Southern California, we did the 30%, and we started to notice some differences in the soil. And that was one of the first things that we saw, was that the microbial population seemed to plateau out a little bit and maybe take a little bit of a decline, and which meant that soils were drying out. The samples were getting a little bit drier than what we wanted to see. And so that was a bar too far. It was too quick to go from 15 to 30% at this time frame. We reduced back down to 15%. The microbial community populations looked like they rebounded fine. The soil moisture was looking good. And then by June of 2024, we reduced to 20% irrigation. Again, summer time frame, hot, dry, and the microbial populations looked fine. And so we were trying to gauge how quickly could we actually make these reductions as we're doing the treatments. And we were just a little too fast, which was a good thing for us to learn through this process. We course corrected and went back down, and 20% is where we kind of landed at over that 2-year period of time frame. Now, do we expect that the soil will be able to hold more water as time goes on? For sure, because we're seeing still more changes in that soil profile as time goes on. So the more that we're able to build this aggregation inside the soil, this water holding capacity, the more reduction that we expect to see. You just don't think of it as like, oh, I applied some extracts and compost, therefore I can reduce water by 30% right away. Depending upon where your soil is at, it may take a bit of time to build that structure to get those microbial communities established. But this is a major win, though. If you think about it, a 20% reduction in water is a huge amount. And so what does that actually really look like? So the nice thing about these smart controllers is that they capture a ton of data as far as how much is going through those irrigation valves. And there's one thing that's a number that will jump out at you quite a bit is look how thirsty turf is compared to some of the other zones. So when we look at pine and palm and camphor, yeah, we saw definitely significant savings in water. But when we look at turf, turf actually is a tremendous amount of water usage. And so if we're able to focus our energies on getting turf alone to reduce water, that's some serious and significant savings. Over that 2-year period of time, we saved about 243,000 gallons of water just in those small little spots. That is a mind-blowing amount of water to be saved. And if you talk about multiplying that across many, many, many properties, that could be significant water savings. And this is one of the things that what I love about working with a client like Tony is that they were thinking ahead. They know in Southern California that water restrictions are going to be part of the normal thing moving forward. And, right now they're not in a drought, but there is going to be a drought that's going to come and it's going to be significant. And the city or the county is going to say, we're going to reduce water that you can use for irrigation by X%. And they want to be ahead of the game. They want to be able to show that, yes, we are able to tolerate those losses without losing all that landscaping or having to rip out a bunch of landscaping and put in these highly drought tolerant types of situations. So this is a huge win. I mean, when we look at this, this is, something that my client can come back and say, all right, these are practices that are going to be achievable, and they're also going to be monetarily sound for us. And we'll be able to keep those beautiful landscapes that we've put so much time and energy into developing. Now, there's the other part of this too, which was we saved water, but how did the aesthetics and the vigor of the plants actually behave through this process? So when we looked at the plant vigor from the control to the test, plants were healthy. They were pretty much disease resistant. They didn't have any of those kind of major problems. But we did start seeing some changes in the aesthetics. And this was for the positive, that as we built that soil structure, we established those microbial communities, the look of the plants became better. So in the turf environment, the grass was fuller. It was a little bit greener. It grew a little bit faster. It seemed to be kind of a more healthy paradigm. When we looked at the palm trees looked great, but some of the supporting plants underneath them really looked good. In the hot, dry parts of the summer, there are some of these support plants that definitely took a little bit of a hit, and you could tell they get a little bit scorched, a little bit, burned. But in the treatment plots, they really shone through. They really, really looked good. And when we looked at the pines, so again, the pine trees look fantastic, but the understory plants, the things that we noticed, the understory plants flowered earlier and they flowered longer. So again, the aesthetic value was up there. Still good vigor amongst all the plants, just that, boy, the aesthetic value looked really, really good. And then when we looked at the camphor, the same thing. So across all four of those treatment plots and the four, main categories of plants we were looking at, the vigor was not a problem at all, and the aesthetic value increased. And so there's another tangible benefit to this, which is not saying, hey, we can also reduce water, but we can also maintain or increase that aesthetic value. And we've got one more here, just looking at the beautiful property that we have between here at Alton Retail. All right. Now, I said this is a tale of two projects. So from that Alton Retail project, we're working on another project. And this is we're looking at olive tree remediation. And, olive trees are a beautiful plant in landscaping. They give great structure, but they're also very expensive. But this particular client, they really like the olive trees. It kind of fits their aesthetic value. And when we put trees in, typically we're putting in mature trees. So these are going to be trees that have been grown out to a fairly large canopy, and they're very expensive to be able to put in. And we have a lot in the portfolio of olive trees, but there's a problem. A lot of these trees are showing decline in health. They're getting disease symptoms. The canopy starting to thin. They're getting pest problems. And this happens usually within a few years of the planting of the tree. And you kind of think about this. You take a large tree, you cut out a lot of the root ball, you put them in a box, they store them for a while, and then they stick them into an area that may not have a lot of soil. The soil around it could be really, really poor. And so now you're putting this very mature tree and saying, go thrive. And it's trying to struggling put its roots out there and get that root mass to match the canopy. And now the trees are under stress. And so we're looking at, well, how can we one, remediate that problem? So we have sick trees. How can we solve this? So this project was really to test, can we restore these trees by focusing again on soil health and really looking at the soil biology, doing a huge lift for us here, which is going to be building aggregation of the soil, doing the nutrient cycling, and doing all that kind of immune system response to help those trees fight off those diseases and pests. And we really wanted to shift from a reactive, like these trees are sick, so now we apply this product. There's this fungicide, there's this nematicide, there's whatever that is causing a problem, to now we want to be very proactive, which is let's focus on soil health and let that soil community and the plants and the microbes do that protection for us. And we want to be able to demonstrate this as a sustainable model, saying that, hey, when trees are sick, here's the protocol that you use to be able to restore trees. And the remediation approach that we used, very similar to like what we talked about in the Alton Retail project. We used the biological rich compost from TVI as a top dress underneath those trees. And then we made sure that there was mulching. Now, my client already mulched. That wasn't necessarily a problem, but what would happen is the mulch would be thin, and then eventually it would decompose, and now you got spots of bare soil. So now you're in this kind of bare soil paradigm, which is really something we want to avoid. So one of the approaches here is saying, let's increase the amount of mulch that we're going to use to be thicker. But we also have to pay attention to this more because there's another side effect that happens when you put microbes in the soil and you have mulch. Well, that mulch gets decomposed. It goes away, which is what we want. We want that decomposition to add that humus into the soil. And that's going to help us increase the organic matter. And again, help us when we start talking about aggregation of the soils. So mulch, but also pay attention to it. Make sure it doesn't thin out. We don't get bare spots. We also improve the irrigation. What we're finding, looking at a number of these spots, that the irrigation was haphazard. You would have these areas of irrigation, maybe in overwatered, but areas that were underwatered. We wanted to make sure that we had much better coverage around the root zone, within the drip line of these trees. And then we use compost extracts. And this is what we use Catalyst Biomimesis for, that inoculum grade compost to make an extract, again, deliver microbes. And here we did something a little bit different though. We do deep root zone injections as well as soil drenches. And all the deep root zone injection means is we're going to take a wand that has holes at the very bottom of it, and you press it down into the soil to about a 2 to 3 foot depth. And we're going to inject compost extract deep down into that soil profile. Whereas a soil drench means we're just going to water across the top. So we do both those things. And then really, this is the idea here, again, focusing on rebuilding that soil structure, getting that nutrient cycling, and make that relationship between those plants work. Now, let's take a look. It's still in progress, so I don't have numbers to share for you. We're not ready to display that. Probably in 6 months to a year from now, we'll come back and do maybe an update to this and say, here's how it's gone. But I do want to show you some of the things that we are seeing or observing from a soil perspective. So here is, we've been in the project for now about 7 months, and really the soils started the same from the control and the treatment. They looked pretty homogeneous as far as their condition was concerned. But one thing we're starting to notice is this level of aggregation. So I want you to look on the left-hand side of boxes, these 4 boxes over here. All these blobs of color in here are going to be aggregates. These are going to be where bacteria and fungi are collecting organic matter, soil particles, adding their own microbial byproducts to create these aggregates. And they're kind of this darker color. And you can notice this aggregation is starting to become much more prevalent in the treatment blocks than they are in the control blocks. And one other disclaimer I have to make. When I look in a soil like on the control, I can find areas that look like this, but it's rare and it's far and few between. What I was trying to demonstrate here is more of this is what I typically see from not the worst or the best, but kind of the mid-grade when I'm looking through the soils to kind of give you a perspective of this. So now when I look over the control blocks, what I typically see is a much more of this mineralization. These are clays and silts that we're predominantly seeing, with a few pieces of aggregation that are occurring, which is typical. I mean, this is what we see in the baseline. This is what we see in these soils, but this right here is not a well aggregated or well structured soil. This is a soil that's definitely having issues or problems with compaction, in which we see compaction as a problem. But look over here, you can definitely start to see the aggregation. And I want to throw a few more things that we see in the soil. And this is just for you guys to see some of the organisms. So here is a nematode, and this is in our treatment block. This is 400x total magnification. And for some of you that may know what kind of nematode this is, in fact, let's just do a thing here. Does anybody want to make a guess? What type of nematode? A bacterial feeding, a fungal feeding, a predatory nematode, or a root feeding nematode? For you guys, just drop it in chat. Let's see if anybody can come up with the conclusion based upon what you saw so far. And don't be shy. There's no wrong answers. I won't
want to
call
see
you
that
out.
mouth. Where's the mouth?
It will be
Where's the
coming back.
nodules?
We're looking
There's
at the butt right now. Hard to tell.
yeah,
Ollie
for
is suddenly
sure.
panicking. He's like, oh, I'm
Yeah.
not paying attention.
Oh,
There we go. Here we go.
Ollie, what did the tail tell us?
Here's mouth parts right there. There's some mouth
Oh,
parts right
okay.
there.
Ooh. Ah,
oh, and then it hides behind the eye.
come on.
There it is.
I feel like, oh, seems like a bacterial feeder. Don't judge me.
Don't judge me.
Don't judge.
Brian said there's no wrong answers, but
But
Being nice.
all right, I won't keep you in suspense. It is a fungal feeder.
Ah,
And what you can see sometimes right there, there's a stylus right there. Right. It will pop in and out. And this is a large fungal feeder. It definitely took up quite a few fields of view. And this is something that I would not have seen in the baseline samples or I see in the control. This is a species I've seen in the compost, and now I'm seeing it in the soil. And this is a great sign to see because this means that there's enough fungal biomass in this soil to support a very large fungal feeder like this. And you can see when I'm looking around here, there are pieces of fungi in here. There are the aggregation. So the soil is definitely changing. All right, let me give you another example. So this is from the control plot. Again, 400x total magnification. And let's see if you guys can guess what kind of nematode this is. And I know everybody's looking to see those mouth parts. And this is what we typically see when we're trying to assess these things is, come on, just stop for a second. Oh, that showed a good one right there. Aha. I think people are getting it. There's another good shot right there. That's a root feeder. And so when we were looking through, both in the control and the treatment when we first started, there was a much higher population of root feeders than any other nematodes by far. And we still see that in the control side of the house, that there is a significant root feeder population. And this matches exactly what we see with the trees. They are a lot of disease issues, pest problems. The trees aren't very vigorous. And also look at the soil here compared to like what we saw in the bacterial feeder. There's some aggregation, but it seems very much more minerally in the sense. The structure is not there, which is where root feeders can thrive. And so this is just another example for us to see. These are some indicators to us about the condition of the soil. Now, there is something I do want to mention because this is a conversation that we've had internally amongst our team, plus something we talk about with our students. Just because you see a root feeder does not mean the soil is bad. I know there's this kind of gut reaction to say, I saw a root feeder. Oh my gosh, panic mode is to go off. I still see root feeders in the treatment plots. But I'm not worried about that because I see a much higher population of bacterial feeders, fungal feeders, and predatory nematodes. Having root feeders in that ecosystem is not a bad thing. They provide a role. Some predation on roots is going to stimulate plants to make their immune system still stronger in that sense. So having root feeders is not necessarily an issue. It becomes an issue when with all I'm seeing is root feeders, or majority of the nematodes I'm seeing is root feeders. And when I see soil that looks like this, I'm going, okay, this is the habitat, the primary zone where root feeders can explode and really provide a problem. So I wanted to make sure I stated that because I don't want to put fear in people's heart to say, oh, you see a root feeder, I have to go to the nuclear option and kill root feeders. It's all in context. Okay. So let's go to this slide here. Now, I kind of wanted to end this webinar talking about the ecosystem of providers, and the story that Keisha had brought up in her part of the presentation was so important, which was it takes a large amount of different skill sets and specialization to really make the urban landscaping environment work as far as transforming it from this agrochemical kind of world to a biological soil health or restorative kind of environment. And it does start with the land stewards, really. People have to make a decision how they want to be able to manage their land. And in urban landscapes, that means homeowners. Cities and counties have a lot of space. That's parks and other municipal areas that are available to the public. Businesses have, landscapes as well. And so anywhere that you're going to be growing plants in an urban environment, the land steward has to make a decision. How are they going to manage or maintain that? And then also we require compost producers. And this is really a switch that's going to have to happen, and it's going to happen, I believe, which is not a focus solely on waste management, but a focus that's going to include making products that have beneficial soil microbes in them so that they become that tool that we can use to be able to transform these places. Landscape architects have a huge role in this. When they're defining the environments, the types of plants they're using, they also can define some of the practices that go along with this. So having landscape architects understand a biologically driven kind of system or ecosystem space, and then be able to apply that is huge. We also have the landscape contractors. These are all the people that are going to be maintaining the land, that they know what the difference is between a mulch that is dyed and, or sprayed with all these other products versus something that doesn't have the chemical contaminants and is something that will readily be taken by the soil microbes in there. That they know to not have bare soil, so the contractor community really has to become educated. There is a huge room for biological application specialists, people who make extracts and teas and do soil drenches or deep root zone injections. Arborists, trees are a very important plant species in the urban landscape environment, and tree care is huge. And arborists that are now looking to say, instead of going to reaching for that chemical when I have a problem, let's try to address the root cause of the issue and give good advice as far as how to make sure to transition from that chemical world to a biologically focused environment. Regulators as well. Regulators have the ability to really enforce and making sure that some of these very toxic things that hurt our watershed, that destroy soil, don't become part of the regular set of tools that are used, that they get phased out and put into more of these biological systems. And you can think on and on and on. There's so many spots and opportunities for people to be able to fit within this paradigm to help change these urban landscapes. And, I really just want to say that, and it's the synergy between all these groups is really what's going to make it work. So this is an area that I think a number of people have really thought, okay, agriculture is the area that we're going to make big changes. And believe me, I deal in agriculture a lot, and I think it's fantastic. But I also think that the urban landscape environment has been kind of off on the side here, and it really needs to be moved more into the forefront to say there are some big changes that we can actually make in this space. So in conclusion, really, soil biology is a very important aspect to this. It really starts with microbes, making sure that we got good sources of microbes that we can use, and that we're also using things like compost effectively and using the right types of compost. And ultimately, what it comes down to is we have to be able to change our mindset and our management practices. If we don't do those things, it won't be very successful. But if we understand why we're doing the things we're doing and change those management practices, that's where we can actually succeed. So that's my talk. Thanks, everybody. Thanks for listening.
Thank you, Brian, bringing the heat,
Thank you, Brian.
bringing the mastery. Oh, it's so cool seeing like all of these things. We see these projects and we're like, oh my God, we have to visit, we have to film, we want to turn it into a video and make our own story about it. And like it's just endless. The amount of projects that I got to visit that Keish and Casey worked on, that Brian worked on, they blow my mind, especially when you see it up close. Like you literally see with your own eyes, oh, this has this is totally regenerated. Like you see the difference in the landscapes that you guys have treated with extract or compost versus the areas where they didn't. It takes these spaces years ahead in the regeneration cycle. And it's just so cool seeing. Yeah, awesome. Well, to let folks know,
I've got a
we're
bunch
gonna,
of questions that are already lined up in chat if we want to just jump into
Casey,
Q&A.
we have
oh,
to,
we're
we
gonna share
constantly
a
have to
little
remember
bit
that we're
about
doing
the
a promotion.
program. We're gonna share a little about the program. We're not gonna spend too much time on it, and then we'll get to some really fun, juicy questions, and even share a bit about the films that we're gonna release, like a really cool film about Gaia Vineyards coming up. But let me share the screen. We've got a really fun program coming up in here in April. And it's a new slide deck. So if you've seen this before, you have to get your mind blown. Well, anyway, so, oh no, that's the last slide. Let's go back to the beginning. Can everybody see that all right?
Yeah.
All right, fantastic. Well, everybody, yeah, thanks for coming. One of the reasons we've all collaborated is to create this really amazing program to bring people from theory to know about the what and why, into having experience, the how of how you create these biological products and services and processes that you actually can regenerate landscapes, that you actually can have an impact on farms and clients. And that's this journey that we've really came together with Compost Academy to try to create. Yeah, how do you continue your training? You know about the soil food web. Like, you've spent so many hours learning about the theory, and now you want to know the practice. And that's what we've tried to establish here, is a practical training program that takes place over 13 weeks starting in April, to really help you gain the experience and the confidence so that you could actually start to restore soils. You can make compost that you know is going to be filled with biological life and actually be able to impact landscapes, soil fertility, and impact yields. And it really doesn't matter where you're coming in from. There's something for no matter what context you're in. And that goes to the next slide. So, for example, if you're a composter, you're a large scale to a small scale composter, there is a way here for you to make effective, high value soil amendments, whether you're somebody starting this in your backyard, a community composter like Domingo, someone who's starting at their farm like Chad Dutai, or someone like John Allen who's starting a larger lot, and eventually someone like Keisha and Casey who's doing this as a business. For soul consultants, you just saw Brian works. He's an amazing soul consultant, and we're here to help you if you're on your own journey to become a soul consultant yourself. This is all about gaining real world experience to move beyond the constant theory and actually get your trials going, make your extracts, see the results on your landscape. And it's all just about gaining proficiency. For growers and farm managers, a lot of people come in here at so many different contexts. We have wine growers, we have people running ranches, and they all just have a need. They want to reduce the chemical inputs, they wanted to reduce that dependency, and they want to get better yields without having to basically poison their land. And what we're going to teach people is how to turn your waste inputs into high value biological amendments and soil products that you know are going to have a beneficial impact on your land and create the best possible crop you can. And for landscapes, you saw Brian works with Tony. This is an amazing service, a biological service that you could add on to your landscaping business. That's very high value. I mean, Todd Harrington established one of the nation's most incredible organic land care businesses just by adding compost extract onto a service. You saw the power that extracts and teas can have on tree care. And that's amazing. You have these extremely high value tree crops that all around the world are in dire distress. And these processes can seriously help protect them and regenerate these extremely high value and like trees that just desperately need care. And that's something that anybody could add on to your business if you're doing that as a landscaper. And just an example, I'm sure you've seen this before. We've got so many new ones I'm excited to share, but I ran out of time on the slide deck. But just this examples on landscapes, the power that biology has to regenerate, these are just a few years apart. You can take a land like in the left-hand corner, Woodshed Gardens, that was totally burned down to ash. And by adding biology, you can regenerate it to a place that it would take a decade or more on itself to get to. And meanwhile, you add biology, you're working with the ecology itself, and you can learn these systems and truly integrate it into whatever you're doing. And so we've got people from all different backgrounds that came to this. And it's so cool seeing the results, the compost that they're making as part of soil mentorship program. By the end of the 13 weeks, like, yeah, they're making it on their farm. They're making it as part of their practice. They're teaching workshops. They're like taking this big waste product on their 10-acre farm when they're just on a tractor, and they're turning into something really incredible. These are just some of the people who've came to the Compost Academy and really starting to see good things. So we have Megan. She joined us here today, Eastside Soil Solutions. So she is a soil consultant. She's helping growers and landscapers manage their soil fertility. She joined because she wanted to really like hone in on practical experience and bring that to the workshops. And she teaches in her consulting practice. You have John Allen. He's a recent ad, but he's been joined by Keisha and Casey forever. He is the urban organizer of the Soul Sponge Collective. It's an amazing group of gardeners making compost and regenerating landscapes across Los Angeles. And recently he took the leap and started his own commercial compost lot with the help of Keisha and Casey. Gosh, what a journey using eucalyptus leaves, a input that is crazy, and just yet turning it into incredible compost. So he took the leap thanks to joining with Compost Academy. Chad Dutai, a great friend of all of us, he really honed in because he wanted to start his high grade and inoculum grade soil amendment business, create his own compost in the same vein as Catalyst Bioamendments, so that he could provide this on his farm where he lives out in Nova Scotia. So all the way out in the east tip of Canada. So he's been joining Compost Academy, so many classes to improve his processes and create that really, really high-end compost. And Jody, she is a wine grower out in BC, and her whole livelihood depends on managing these vineyards in the right way. She manages other vineyards. She grows her own wine. So she's dealing with an extremely high stress situation, but she came to Compost Academy because she saw the need that compost could, like the impact that compost could have on our land, because she was drowning in input costs, drowning in stress. And thanks to compost, she's able to shave off so many layers of costs to really help increase the output of the vineyards she manage and grow the best wine that she possibly can. And it's so cool seeing her journey from, joining us at a retreat in Costa Rica to now putting out compost on the land and actually seeing herself grow better wine. And so what is it all about? It's about camaraderie. None of us wants to do this alone. We want to join a group of people doing this together. And we want, you go far together, so you don't want to be just dropped in a class that, oh, great, I'm watching videos. No, we want to do this together. And that's part of the reason we put this together is we're doing this over 13 weeks with Keisha, with Casey, with Brian, with myself. Everyone's going to be part of this amazing group challenge together. You're going to get an expert coaching based on practical experience. You're going to increase your competency. Everything is based on action. There is a little bit of theory, but it's based on professional, practical experience. And of course, one of the best part is the challenges. You're going to be challenged to go out and make your compost, get your recipes together, collect all your inputs, put them together in a really amazing chart so it's easy to track. You're going to make extracts and teas. You're going to apply it. All these things are gathered to put together to make sure that by the end of that 13 weeks, you're actually doing something and you're getting a result. And of course, we want to create amazing professional networks. We want to help you no matter where you're at, no matter what your business is. We're here to help you to become part of basically a family and a community. And so a few things we're going to learn about: wide spectrum composting techniques, thermophilic composting like Keisha and Casey shared, static composting, vermicomposting. You're going to learn all about biological extracts and teas, how to brew, scale, apply them, reducing toxic inputs with compost, big expanded case studies from vineyards to burn down landscapes regenerated to farms. You're going to learn more about the practical side of soil biology that, we love the theory, but, more of the application on it. And then different composting on different scales, like whether you're starting small and what you can do with it, or the large scale and what you can do with that. And of course, how you manage and gather and create amazing recipes for your compost. So what's inside the program? You get 13 weeks of live group coaching with Keisha, Casey, Brian, and I. You have a self-paced training course, tons of modules that really increase your skill level and fill in any gaps you might find. You've got an online in-person community. You're going to join dozens of people in the cohort, and you're going to have really fun bonus sessions, whether it's extracts, nematodes, microscopy. It's going to be a fun time. And all this together, I think it's a really nice, it's a great deal. We're really stoked to bring this together to everybody because we do this really only once or twice a year. And yet I think it's one of the best offerings that you could ever be a part of. Like, you're getting real expert training from everybody here, and you get free access to the next one. So if you join this cohort, the next cohort you get free access to. So it's not just a one and done program. You get access to the next one and the next one. It's just a really amazing value for what you get. And of course, you get free access to the self-paced training program. Normally it's $850, but everybody in here gets it free. They're going to throw in bonus sessions like microscopy. It's going to be fun. And you get discounts to the future other programs we run, like the microscopy program. So you get so many like layers of what you get from being a part of the Soul Mentorship Program, which we also call the Live program. So this program starts April 9th. It's only $1,750. Basically, you get $200 off if you make a refundable $200 deposit by February 28th. Maybe we'll slide into March 1st. It's all good. But we encourage everyone to jump on in because we really want you to join our cohort. And this spring and summer, just get amazing results on your land and create the best compost possible. So I'm going to drop a link in the chat and hopefully we can see everybody in there. And just
Yeah, I want to add to this too, Raleigh, if I
Go for
can.
it.
Really quick. So it is kind of fun. Raleigh mentioned like you get to keep going over and over and over again. And I'm saying this to tell our students that are here today that have taken the time. Brian and I went a little bit after we did the microscope course and we changed our teaching structure. We got so excited about it that we're actually reformatting the whole program. So it's going to be even more information, probably longer classes. We've been behind the scenes every day having these meetings like, how can this hit harder? How can we change it? Who should present this? So I think it's like it's cool because the information actually does change every single time. So it's not just like these videos that are playing over and over again. We really put a lot of energy into cultivating what we're putting out, trying to make sure that it's working for everyone. And I want to say we try to push our students to give us feedback, and they've been so happy. I'm grateful for all the epic feedback. But we continue to push ourselves into a different direction, and we have a lot of fun with it. So for everyone that has invested in us so far, we really appreciate it. We love our
sure.
jobs. We're having a crazy good time at work.
For sure. Yeah. And that's,
Yeah.
we change too, we're evolving. And so as that's happening, we're looking at our courses saying, hey, there's new information. We want to be able to, or wow, this hit better when we worked on this project. We need to be able to expose that in our classes. So yeah, it's been great.
But the most satisfying thing is just seeing the fractal of what happens for people who come in, like, whoop, like, oh, now John Allen's, doing a compost lot, like, whoop, now Jody's doing it on her vineyards, whoop, now like Megan's teaching. It's just so cool seeing
It's fun.
everyone like taking this, running with it, and going to places we never would have expected.
Well, yeah, and the students lift each other up too. Like I don't know, like Chad is such like he's so silly and fun. Like the way he operates is like different than all of us. And we all got to watch him go from hand turn piles to like tearing his ACL or his it was a really important part.
Achilles.
Achilles
yeah.
tendon. He went through all this drama and then he came back and he found a way to buy his turner and he shares it all with us. It's a super cool community. We love it. And we do wish it could all be for free, right? So it is. We're going to keep doing these webinars. We're going to probably start a podcast very soon so we can get more information out easier. Not to pre-drop that. We still got a little
secret
ways to go.
podcast.
But yeah, we love this. We love this. Every time we get a promotional period, we have a good reason to host these webinars and just be in community with all of you. So thanks
And
for showing
don't
up.
tell anyone about the epic Alex Whiteside's vineyard video that's about to drop
Drop.
Yeah.
tonight or very early tomorrow morning.
Hint.
Shh.
Wink, wink.
Oh, and for folks who haven't seen it, I'm going to drop the link one more time. We made this really beautiful film about Keisha and Casey's work helping the Woodshed Gardens recover from the 2018 Woolsey fire. It's just this beautiful regeneration story. So if anybody hasn't seen that before, definitely give it a watch because it's just an incredible story of what biology can do. I'm dropping it in the chat right now. It's up on our YouTube.
This has to do with post-fire mitigation. So somebody asked in the comments if any of us like if we work with consultation post-fire, and where Brian works mostly with large-scale agriculture, we're working with. We live in a fire-prone area, and we ourselves have burned down and had to reach out to our community. So it's a very natural progression of us moving towards working post-fire. But that's what that video is all about. We're going to have a few more coming out, and anyone in the group that is trying to work, in disaster relief, helping people, prep their own soil, I would be happy to connect you with the right folks. I know a lot of groups of people that are doing incredible things in that lane. So just connect with me privately if you want some connections with them. Casey, you want to do the Q&A? Let's go.
Let's do it. Let's do it.
Baby.
You over there like, oh.
Oh, chomping
There's
at the
questions.
bit
I
for these
saw
questions.
someone lowered their hand.
Oh,
should we do a
it's still at
live
the
one
top there. I
first?
guess we can give the hand raiser.
Okay, we'll
Michael.
do a live one first. All right. Michael, how are you doing?
Are you
Good to
there?
hear
You're
from
muted,
you.
Michael.
I
There
don't
you
know. I don't know why I raised my hand.
Oh,
Oh, no worries. No
mystery
worries.
hand raise. Okay, no
All
worries.
good.
Yeah, so
Well,
it was like a butt chat, I guess.
okay,
There you go.
okay.
Well, it was
Butt
good to hear your
chat,
voice,
butt
Michael.
hand raise. All right. Well,
Yeah.
we'll lower your hand if you have something you want to ask live. Feel free to raise your
Raise
hand
it
again.
back
Uh,
up.
yeah,
Feel
thank
free.
All
you.
right.
Okay.
I guess Keisha, first ones here I'm seeing are about the compost section, but Charles asked lower temps like 135 to 150.
Yeah, I mean, yeah, definitely. Often we're in the below 150 range. I will say we still like we had a pile recently, windrow 3. You saw the picture of it. It had the green grass. Um, the grass grew, that's wheat. It's wheat this time, right, Case? It was wheat this time, and it grew exceptionally well. We don't always get that kind of growth on a windrow, but we ended up with a stand about this much of this fresh grass that's just got all this nutrient. And our first turn, it did hit 160 for 24 hours. So I'll say it still does happen, but we manage it. We don't let it sit at 160 for a long time. You know what I mean? It's like 24 hours max, and then we turn it again. But our ideal range is, yeah, under 150. There's a lot of play in it, and those microbes still survive. It's just how fast does the ecosystem come around? How robust is it? At those low temperatures, you see it with the microscope. Almost immediately, pile will still be hot, and it'll be up to biologically complete standards. You'll see an ecosystem present. So,
Yep. Nice. Uh, Q. Hey, Q. I didn't know you were here. Q
Q's
asked,
here.
what would you say is the maximum size wood chip or chunk you would want in your compost pile? I guess I could take that one
do
because really
it.
it's like maximum size, like it's more about like kind of diversity of sizes. You don't want everything to be completely uniform in size. So anything from like a half inch, I guess you could say. You don't want to go super fine. Super fine stuff will tend to stack. But like half inch up to, I mean, we even have some like branches and sticks like that in our piles that we pull out later, that just help with a lot of structure. But really, like for the majority of them, half inch to 3 inch chips, somewhere in that range is kind of the ideal zone, I would say. Nothing to add, anyone?
Well, the
No,
Turner throws out the big ones, so.
Oh, that too. Yeah, the
One of my
Turner's
jobs is to
great.
walk up and down the windrows after we turn and huck the big sticks to the hill. And then they take their fungal ways to our pasture, and it's just fun. Go ahead, Case.
Nice. I'm reading down real quick. Sorry, there's a bunch of. Oh, this one looks like for Brian. Are there specific sets of tests that you ask for on the chemistry side?
Yeah, I like pH for sure to be part of it, which is typical for almost any chemistry analysis. The one that's sometimes an add-on is soil organic matter, so making sure that that's present. And I like more than just NPK. I want to see a lot of the micronutrients that are in there as well. So that's really where I'm looking at in my soil chemistry. And the biggest thing I think with soil chemistry analysis too is if there's a history of soil chemistry, because that's more common. So people may have been taking soil chemistry every year for 10 years. Then I don't want to change what they have been doing because I want to see what changes are made from the time we start doing our treatments to that exact same test. And the other thing too is make sure you use the same lab and the same methodologies when they're doing soil chemistry analysis, because depending upon the extraction method they use, you get wildly different results. So switching labs midstream or switching the test methodology just really makes the data incongruent. It becomes really hard to make heads or tails of it.
Yeah, agreed.
Yeah.
Case, before you move on, I got a question here it's so relevant.
Uh-huh.
Susanna just asked is I tried to hint on this earlier, but have you guys worked on no turn piles, maybe for smaller scale farmers and homesteaders? And absolutely yes. This is, in Compost Academy, there's so many ways to grow microbes. We have experience with a lot of different pile styles. You've got your Johnson Sioux, you've got static piles. There's really a lot of different ways to compost and to compost with a focus on microbes. So a lot of the things that I shared with you today, the little tips, ways that we were different, those actually cover across all the different composting ways, right? So when you come to Compost Academy, that's the first thing we look at is where are you at? What are your goals? What's your space look like? What kind of input materials do you have to deal with? And how can we help you figure out a way to use one of these hundreds or thousands of tools that are available to us to reach your goal? So we're setting goals and then we're looking at all the different ways that we can move forward. So yes, if you look out in my yard right now, I have a worm bin, I have a worm pile, and I have a static pile. And I also have a pile that's moving towards thermophilic because I put too much food waste in it yesterday. So yeah, we do it all. And you can grow microbes in any of those ways and even beyond. So
Nice. So Jason asked, do you perform your own DNA analysis or you send it to a lab? If you send it to a lab, which one do we use?
Definitely
sure,
sent to a
Brian.
lab. Yeah, I don't have the equipment, not making that investment to put it in my own my lab. There's plenty of other providers out there who can do it a lot cheaper. Biomakers is probably something that we use mostly, I'd say in the US. Although there are a lot of universities that will do DNA testing really for the cheap. As well. So reach out to your local university to see if they have a service to do DNA analysis. Now, there's a thing about DNA, though. It is a technology that is evolving and getting better. Some places test DNA and they'll only do bacteria. Some will do bacteria and fungi. Some are now adding protozoa and nematodes into those equations. The more you can add on, it gives you a richer picture, but that's usually also going to be a little bit more cost. The other thing with DNA analysis too is that still a vast majority of bacterial and fungal species that are being tested, they don't have any primers for, and so they come up as inconclusive. And so you're going to get a large number that's going to be like, I don't know what it is. It's bacteria, but beyond that, we don't know. So just be aware of that as well. It's still a technology that's getting cheaper and evolving. 5 years from now, I expect that wow, DNA will be an easy tool for us to be able to reach to with especially financially. It will make a lot of sense.
Yeah, I want to answer that. And then there's another question I saw that I like. The DNA thing, Matt Powers has started popularizing doing DNA analysis in his class. And I believe he got his information from William Padria Brown, who's also known as Mycosymbiote on Instagram or YouTube. He's pretty famous at this point. Um, it is neat, the technology that Brian's talking about. It's this unit that you can do your own DNA analysis. Matt and I are pretty close. He's poked me about doing, getting involved. He's like, you'd love this. For me, the unit's still a little bit too expensive, and I don't have a ton of time to take more classes. But in the future, just for fun, I really do want to get involved with that. Like, I think it's super cool. We had a private question, so I won't name the person that asked it, but it's a good question. And I'll expand it out from the person asked, how is our class different from Matt Powers' class? And I'll expand it out as well to Soil Food Web School, because this is a question we get every single time. Like, what am I going to learn that's different? And in a lot of ways, depending on what Matt Powers class you're talking about, he teaches so much different stuff, right? Like we're not teaching permaculture, although we might talk about it if our students want to. Um, and our class isn't the class we're talking about that's coming up is not focused primarily on microscope work. We talk about it. We talk about microbe identification. It's a part of what we do. But more of what it is a guide on how to take these skills that you learn at Soil Food Web School, how you take these skills that you learn with Matt Powers and make a career out of it. Because I don't know how many of you like this is my story is I worked with Dr. Elaine at her old school, almost graduated that until it went up fell apart. And then there's a new school. We worked there. We've been very, very involved in every single part of soil food web reality that you can imagine. And we are consultants and we make dang good compost. Catalyst was built way before we were consultants. We knew how to make teas and extracts. And I tell you what, when I got to the real world to be a consultant, it honestly felt like a slap in the face how I was so unprepared. And that's not to say anything about like, oh, Dr. Elaine didn't prepare me. She gave me the foundational knowledge I need. It's learning how to be bold and move forward and work in these groups, right? And for me, I feel like I had this extra edge because I did have Dr. Elaine in my ear. And when I would call her and say, Elaine, I don't know what I'm doing, she would be like, you know what you're doing. Just do your own study. She always, instead of telling me what to do, she just always told me, you can do this and was a foundation for us. And I think that's really like, I mean, it's kind of like, I think that's our mission here is to just be a support system and help you guys figure it out. Not that we know everything, to be quite honest. I'm learning as much or more from our students and our community than I think we even put out. But that's the point, is we all land with this great information in a space that's not ready for us. Our jobs don't exist yet. If you go out and say, call your local compost producer and ask them about nematodes, they're going to laugh at you. We have a long way to go before this is a real career. And this whole, what is it, Brian? The rising tide lifts all ships. You
Sure,
say that
yeah,
all the time.
yeah, yeah.
In my mind, like my distributors are like, you're out there making us competition. And I'm like, no, we are out there creating an industry and we need help. So, you guys out there doing this work, like that's what's going to make the change, especially if we're looking at Dr. Elaine's mission and we're trying to accomplish it, right? Like we've got to work together. We've got to figure out how to work with these people that don't maybe know who we are yet. And so I think that's where we kind of shine, is in support. Although
Building
we do teach
community.
people how to use compost, all the things that you learn there, you're going to learn with us too. Maybe not Matt Powers though. Matt's wild, like that's what I love about Matt, is he's not necessarily doing the same thing as anyone. Like his brain likes to just go out and find all the new information and bring it in and try to organize it. And he's a force of nature. I've watched Matt for years. We're friends. And he'll change his mind. He'll teach something. Okay, I'm changing it. It's different now because he's constantly evolving. He's constantly learning new things. And he's definitely different in that way. I mean, the presentation we put on today is very representative of how Brian and Casey and I are. And the way that Matt presents himself as well is very representative of how he is in class. So I think they're all good places to study. And a ton of our students are
In all
students
of
of
them.
Matt,
All
students of
crossover
Sophie Love
anyway.
School,
Yeah.
Yeah,
students
it's
of Joe Tobias.
yeah, it might come from Matt. It might come from Elaine. You might be like part of water stories. Like we're all just weaved together so deeply. It's
Yeah.
pretty fantastic. Oh, well, I see
Uh,
some real, there's a lot of open questions in the Q&A. How about we
Q&A.
jump to some of
Go
those?
for it.
All right. Well, first one, Sophie, you waited so long. Sophie's asked, when you applied solid compost to the landscape, did you incorporate it into existing soil or was it spread on the surface?
Spread on the surface, typically in like a landscape environment where you already have mature plants and so forth, incorporating into the soil, you can do a lot of soil disturbance. Usually not the best method. There are some certain corner cases where that might be the right thing to do. But for this particular project, we definitely just put compost on the surface of the soil and then recovered that with mulch. You can use compost as mulch, but boy, if you can cover the compost with a mulch, that's even better because now all the microbes for that entire layer are going to stay nice and moist. They're going to have that water profile that they need to be able to start doing that work. And then all that mulch is on top of that compost, it gets composted. I mean, it's breaking down, turning into humus. That's what we want to see, incorporating the organic matter back down the soil. And there are plenty of organisms that are going to help take that humus that's built on the surface of the soil down into the soil profile. When you start digging through these environments, there's tons of earthworms and other microarthropods and things like that that are going to make holes in the ground. Even gophers. I mean, even though we don't like to see them necessarily because they can harm some of those landscapes, they could still pull a lot of organic matter back down into the soil. So yeah.
And create drainage.
And great drainage, exactly. Yep, yep.
At John Allen's, it rained while we were building compost, and we were like, "What are we gonna do?" And this gopher, like this, I swear it was one gopher, made
show you
such
the
work
way.
of draining the bed. We didn't even like it. Just looked like a plug got pulled. It was like, and it was just, it was really. I was like, "Oh wow, gophers are really good composting partners."
Thank you. All right, Raleigh, another one from the
Oh,
Q&A.
sure. Let's see if Charles is still here. It's a very what Charles saying, I find Netafin irrigation tube spaced at 12 feet interviews does okay with landscape planners, or maybe it's 12-inch. But when I check for mycorrhizae, they are present near the water source, the drips from Netafin, and not outside the water drips. Another example, grapevines are watered by drip tape or Netafin tubing. I found plentiful mycorrhizae in the root by the water source, but not in between the rows. Cover crop. Shouldn't we water overhead mimicking rain through all the land?
Yeah. So the question is that, basically, what about drip emitters versus like micro sprays, bubblers, those types of things? And I'll just give you this advice that emitters can have their place, but if I'm going to be using emitters, I'm going to make sure that I have a good layer of mulch around where that emitter is at. Because you got to figure when a drip emitter drips water into the soil, it's like an inverted, or it's like a pyramid as far as the water is concerned. It will plume down and outward, but you'll have these areas of soil that will get really dry. Now, if you put mulch, a good amount of mulch on top of that soil, then that dry area soil then starts to get rehydrated because the evaporation is not so intense, and you'll get a better coverage that way. Now, in a lot of landscape environments, like with the trees, I like the micro sprays or the bubblers because you can spread that water out over the drip line area, and it creates a moisture layer, a significant moisture layer between the soil and the mulch, which then helps again with that decomposition and a breakdown. So you can use both, but if you're going to use emitters, I would definitely make sure you have a good mulching paradigm that's in there. The other thing that I like about micro sprays and bubblers is that I don't have to really worry too much about clogging. So when I start using extracts through what we call fertigation, which is simply I'm injecting an extract into the irrigation line, and I'm going to use the existing irrigation to distribute those microbes. They don't clog. With emitters, it's in a mixed bag. There's a lot of emitters that will clog at the way we filter our compost extracts. And so we have to do additional filtering to make sure that we don't clog those emitters. So there's a little bit more work when we typically talk about emitters. Now there are emitters though that are out there that are rated for our particle size that we get in compost extracts, but not many of the manufacturers are kind of in that space yet.
Nice.
All right.
I have a quick, easy question here.
Mhm.
What's that probe called that we put down amendments down into the root zone, Brian?
Deep root zone injector. Oh, and I have a piece of advice for you in this. You can buy deep root zone injectors online all over the place. And if you find them, they're like $39 or $40. They're going to be made probably with very cheap metal, very thin tubed, and you're going to push it into a highly compacted soil. You're going to bend it or break it right off the bat. I typically look for going to like an arborist supply place. They make very heavy duty, thick walled steel where my entire body weight, I'm a big guy, I can put my entire body weight on there and I'm not going to bend or break that deep root zone injector, so I can punch through these highly compacted areas. They can be pricey. You know, you're on a good injector, you're probably going to be spending a neighborhood between $300 and $500.
They're a little cheaper at PBM Tank Supply, I think. I just
Oh,
checked
okay, good,
there.
good.
You can, that's who we like. PBM Tank Supply. They're just awesome. They understand microbes. They understand pumps. They're the best. They'll talk to you for free all day. But they build their own injectors, and they're pretty strong. The gauges on all of ours are broken. The freaking handle breaks, but the idea is just get
It
the
works.
extract in the ground. I can't say that they work forever. They always break, but they're super strong and they don't bend. So
Yeah.
we
The part
tend
that
to
breaks
use
is the trigger. The trigger wears out
it just
eventually.
drips
Yeah.
But it's
extract all over you.
replaceable. And then really what I do now is I just pinch my hose when I'm going around and then let that off instead of use the trigger.
Right.
It works.
It works, yeah.
The pole has not worn out yet.
Right, exactly. The steel pole is fine. It's all the little other parts that go along with it.
Our
Yeah.
pressure gauges are blown, but everything else.
Yeah, and the
Funny.
pressure gauge.
Got any more, Raleigh?
Oh yeah, oh there's heaps of. I mean, there's like a three-parter from Dominic, but let's get to Charles first. He says, "I'm a soul food web guy. As a landscaper, I use my compost piles as an inoculant for decent compost for other places. I check with both my microscope, but what will be a good ratio of biologically complete compost to okay compost piles? Example, one of your good compost to five of theirs."
Oh yeah. So that one, it's tough because it is always that it depends. So if the compost that you're putting it into is nice and moist, that's a really good chance that microbes are, some organisms are going to take up and start reproducing. Um, but like I said, that photo that I showed you of that overhead windrow, that's 5 acres of windrows. Those windrows are Casey's better at numbers. They're huge. It's such a volume of compost. And
1,000
they
yards at
used
least.
2 yards of our compost, which is like, it's such a small fraction. It's hard to even understand it.
Oh yeah, that picture was like 15 to 20,000 yards of compost.
Yeah, so
Yeah.
2 yards to 20,000 yards.
Yeah.
But they, like I said, they work on their moisture. They were taking care of their compost before we got there. We had another person that bought, gosh, this was a tragedy. He cleared our compost lot. He bought 80 yards of our compost, and there's another compost facility that I will for my whole life leave unnamed, but they like to promote their compost as being a fungally dominant compost that is paired up with SFW techniques. And the guy bought 80 yards of our stuff and 80 yards of theirs and mixed it together, and it killed everything in our compost. They're like,
Oh
couldn't
no.
find any life left at all. And it was just like, I don't know how or why it was killed. I do suspect there was a large amount of humic acid that was mixed in powder form,
Linardite powder.
Linardite, into the other compost to make it look
Mm.
dark and rich in color, because that's a good trick the compost producers will do. Because soil food web people know, right? When you shake up your test tube of compost, if it like if that darkness doesn't settle, that's humic acid and it's good compost. So it's a little trick they use, and I'm wondering if it didn't hurt our microbes, but I don't know. So many times bad things happen and we just can't quite trace down exactly why, because we don't have the funding to do extensive testing over years, which is why this study is so special, because we actually got some clarity,
Right.
some valid clarity to what we're doing.
Thank you, Tony.
Yeah, thank you,
Man.
Tony. And thank you for continuing the work.
Yep.
We he wouldn't be mad if we said we love his money.
No, we love Tony though too.
We love Tony. No, he's great. All right.
I'm reading.
So
Well,
many
there's,
questions.
it
It's
seems
so
like,
much.
oh, here's an easy one from Jim. When using compost in an urban environment, does the frequent irrigation with treated city water kill off many of the microbes?
Yeah, that was a concern that we have for sure. I mean, there are things you can do to mitigate that. You could put carbon filters in your irrigation that will try to bind up that chlorine or chloramine that you use. In the Alton Retail Project and also the olive tree remediation, we don't do any of that. We actually just use the municipal water that comes to us. And I think there's a special case though too. When we look at that, we're using reclaimed water, and so it's not going to have, if it is treated, it's very low concentrations of chlorine and chloramine. But we've used this also in other landscape environments. Compost itself has a pretty large battery as far as being able to tie up chlorine and chloramine. That word "it depends" is going to come in there as well. If you have a water source that's coming really close to the water treatment plant, is high in chlorine and chloramine, over time, yeah, probably you could result in some kind of microbial damage, or not being the microbes establishing quickly because of that negative pressure from the chlorine or chloramine. If you're way far away from the water treatment plant and have very low amounts of chlorine or chloramine, then the impact would probably be completely negligible and you wouldn't even notice it at all. So when we're using compost and compost extracts, it does a pretty good job, I think, of binding those things up. But here at my own house, I have carbon filters I put on my watering sources that I use to water my landscape, just to make sure I remove it out of the equation. That's a personal preference of mine. I'm sure I could probably get away with not using it and still do okay, but I still want to mitigate it as best I can.
Yeah, we use chlorinated water in our at-home compost, and it's pretty impressive actually, like
Right.
what survives. It might be able to be better, but it's really good. I wanted to ask you a question, Brian, when you said that. I remember the presentation we did together, and where you talked about you had a client that you taught to use the microscope, and they were using the microscope basically. It was in the Atom group the other day. They were using the microscope basically, and they caught a water problem.
Right.
Does that resonate with what he asked?
But it kind of a little bit different scenario, but the same kind of issue. So what Keisha was describing was a client of ours doing pistachios, ran into an issue where well, I taught them how to use a microscope. So they were able to quickly just do their own qualitative kind of assessment to see how things were going. And we were doing treatments, and the you could see the microbial community was moving along, and then all of a sudden it was like, wow, the microbial community looks different. I think it's declining. Something's degrading. The tree still looked great, but he saw the result. And I took a sample, sent a sample to me. I looked at it and said, yeah, something's off here. And we started brainstorming, like, well, we're still doing our treatments, haven't changed anything. And then somebody went, oh, we switched from canal water to well water.
Mm.
And then we were like, okay, well, let's take a look at that well. Well, they just dug a new well, and it was 2,000-foot depth, and it was full of bicarbonates, extraordinarily salty. A lot of salt it was in there, and that was causing issues. We were putting the land and the microbes were not able to overcome or bind up all those salts effectively, and so it impacted the microbial community. my client had to then put a treatment facility in for his well water to make sure that he pre-treated the well water before it went out into the fields, and that resolved the problem. Microbial community rebounded, boom, off we went. So
Isn't that a bummer? It's like the chemical that you would think like chlorine, you microbe killer, you.
right.
It's like not really killing nematodes or testing amoeba or naked amoeba, but then like you have this wholesome well, like oh finally
Yeah,
like
right.
back to land
Water
water.
from the
It's
earth.
like sorry, the salts.
Yeah.
That's kind of that's not what I expected. I forgot the whole story.
Right.
Kind of a bummer.
A lot of it, what our job is, we are detectives, really. At the end of the day, a problem presents itself, and we've got to ask all the right questions, put our detective hat on, and then work it backwards until it's like, that's potential source, test it, make sure, and then, all right, now how do we, remediate that problem? But yeah, it was one of those ones where you're like, we're all scratching our heads at first, like, what are we doing? We're still applying the same. I mean, I looked at the extract, looked at the teas. I was like, all right, everything's looking great. What you're putting out in the fields is what the quality you've been putting out in the field, but it was the irrigation water they were using switched to the well, and that was it.
Ooh.
Yeah.
Wow. There's an interesting question here about using compost teas to reduce copper concentration. It looks like they live in a mining town and their crops have difficulty growing because of copper. I've not had any experience with copper, but I do have experience with manganese toxicity. We are in a mining town as well, where I live, and up in the hills where a lot of the mines were, a lot of the wells now produce, well, there's a lot of arsenic, but there's also a lot of manganese, and the manganese, the plants have a hard time growing through it. And I have some clients that we didn't do any studies or anything like that, but he started focusing on his microbial community and has reported no issues for the past 5 years or something. Now that he's got his microbes in place, there doesn't seem to be an impact on his plants from the toxicity, but Brian can probably.
He did test the well water though, and it didn't change at that farm.
Oh,
And
yeah, yeah, yeah. Yeah,
really,
Mitch, yeah.
he kept
Right.
checking the well water to see if there was actually changes going on, but it was actually the shift in his practices that kept the toxicity from taking over.
Yeah.
It's like with copper, it's heavy metal. It's not going to go anywhere, but it can get bound to where
Right.
it's no longer impacting the plants in the same way. If you have a lot of, microorganisms in there that are consuming it, taking it into their bodies and holding on to it, it might not be leaving, but you can mitigate a lot of those side effects.
Yeah,
Yeah, I mean,
we see that in agriculture all the time. I've a number of clients that have aluminum toxicity. So when you do a soil chemistry analysis, the aluminum is just off the charts. And really what's happening with a lot of these plants is a way that plants absorb nutrients. Some of this is very passive, which means they have no choice but to absorb way too much of that nutrient into their body. And that then ends up blocking the absorption of other critical nutrients that might be in perfectly well balanced in your soil. It's like they're there, but my plants aren't actually, pulling those things in. And for any of these toxicity kind of levels of nutrients, we use compost and compost extracts that are high in humic acids because they're binders. Basically, that humic acid is just a huge battery. It's going to chelate, or they bind the excess amounts to the form of the humic acid, and now it's no longer going to be absorbed by the plant. So you've reduced that toxicity load. So my advice to you would be focus on creating really good compost that's high in humic acids, and use a lot of extracts, and keep on putting extracts out there. And hopefully over time, what you're going to do is you're going to start to bind up those toxic levels of copper, and then at that point, hopefully get into a balance as far as what the plants are able to consume. One of the things you can do too is you can do a plant tissue analysis, and that will give you the good result as far as saying, hey, I still may have a lot of copper in my soil. I might be doing soil chemistry analysis and still seeing a lot of copper, but is my plant at those toxic levels of copper? And have I been able to change that paradigm? And usually you can find plant tissue analysis for pretty cheap, 30 to $50. Just to verify that, yeah, what I'm doing is actually working from the plant standpoint.
mhm.
Let's see.
I have one of
Also, I
those.
just want to say 3 cheers for William. William Hedger just joined. Welcome to the cohort. Welcome to the
William.
Oh, cool.
Good to see you, William.
2026 cohort.
We'll get to know you soon.
Yep.
Very soon.
Yep.
Hey, there was a question. Oh, there's two good questions now. Joseph, let's get to one of his questions. We love Joe. Do you calculate carbon sequestration increase as soil organic matter increase? Good metric in some environments.
Yeah. So soil carbon for sure. There are many different ways to test soil carbon. Um, and I would say this is a place the technology is definitely changing and increasing. So there are better methodologies to be able to do that. But yes, the soil organic matter is a form of carbon. And it's amazing because a lot of people think of soil organic matter coming from plants, the residue of plants or roots that are decomposing, and that's going to add soil organic matter, which is very true. It definitely impacts soil organic matter. But another component that impacts soil organic matter is the microbes themselves. All those biofilms, the extracellular polysaccharides that bacteria, I'd love to throw out those words. That's the biofilms. That's the biological glues that bacteria create, full of carbon. When you look at fungi, when they create glomalin or glomalin related substances, again, that's their biofilm, their biological glues. They are full of carbon as well. And, they are going to add to that soil organic matter metric that's there. Now, as far as speaking to specifically different carbon sequestration tests, you know what? There are so many different ways to do this. I think this is going to one of those ones we're going to want to tackle like in a podcast and really kind of dive down into it because it depends and there's a complexity to it that I think deserves some justice as far as speaking through it. So
I think anyone that knows this knows that we have to have the podcast because we're just getting exhaustive in class. Like our classes went from 1 hour to an hour and a half to 2 hours. And we always start by, there's so much more I want to say.
Exactly.
We'll just have a 24-hour live stream.
Dude, it's ridiculous.
Yeah.
Live stream forever.
Watch me sleep. Watch me eat food.
Yeah, I remembered that we needed to bring up biochar. Someone asked about it, and I
Of
promised that we
course.
would talk about it. Comes up almost every single time. Do we add biochar to our compost production? We do not add biochar to our compost production, and for multiple reasons. One being, we want food for our microorganisms to reproduce. Biochar is often touted as a home for microbes, so it might make sense. Like you put the house in and then you feed them and then they have a happy life. But when they're actually growing in the compost pile, we want to have as much food resource as possible. So instead of taking our wood chips and charring them first and then putting them in, we skip that whole process and we put the full wood chip into the pile. This provides an epic home for the microorganisms, food for the microorganisms, structure for the microorganisms. Now, another reason we don't add biochar is because I am a freaking stickler on quality. And like David brought up SB 1383, which is great. We don't want to have organic materials in the dump anymore. But what's happening is all of this very low quality biochar that's coming from the electrical industry is getting dumped onto our farms and towns. They call it free. They're like, this is a free gift to everyone. And it's not a product that you would really want to use in your soil or even at your house. Now, there is really good biochar. We're actually in community with the biochar producers around here, and they're reducing fuel loads and making biochar in the way you should. And this is a really complicated subject that we cannot bridge here, and it's not my specialty in any way, shape, or form. But there is a difference in biochar, just like there's a difference in compost. So when I go to price out the biochar per yard, it costs almost as much as our compost. So
or more.
So for us, I would have to double the price of compost if I wanted to add biochar, and I'm not sure that it would add anything to our piles. Now, someone said, I think about adding it for moisture maintenance, and this is the third reason that I don't like it in my compost pile. It's because right now, when I'm building my compost pile, there's this beautiful sticky structure, like a sponge that gets created. We call it the squeeze test, where you squeeze and you listen, oh my gosh, is it holding water? If your microbial community is present and they're eating and they're reproducing and they're making their happy microbe home, they will hold water like ain't nobody's business. And it's very easy to maintain the water as long as you stay on it and you don't let it dry from the outside in. Now, in my experience, because I've done a lot of trials of mixing our compost with biochar because people really want me to do it. And I'm not sure why, but forever, ever, people are like, you got to add the biochar. For me, the biochar just throws the whole game off. I don't know my product anymore. I can't understand it. It feels wet, but it's grainy and it's not sticky anymore. But it's almost like it's dry, but it's wet. And do I water it? Is it holding too much moisture? it just throws it off for me. And I know there's a lot of people out there that are like, biochar is the most important input in my compost pile. And for them, that's probably true because the way they've set up their operating procedures is, they understand that texture, they understand the way it's working, and it might be a really great way. For me, it's an added cost, an added project, and an added confusion. And so I am still honestly playing. You see my houseplants in the back. I'm always doing weird blends with my houseplants to see what's going to grow wetter, what's going to push it. Brian and I have a client that almost all of their product is biochar. A very small percent is compost, and it grows houseplants like it's just so good. But I've replicated their techniques with other biochar and had really poor, poor, poor results. Stunted plants for like a year, which is not normal in my house. So that's my bit on biochar as of today. It's changing every month, but anyone else?
I think you hit the nail on the head, which is well, I know Casey's got some stuff to say too. I'll make mine quick. It's just that, you know, it's just like compost. There is a variety of quality of products that are out there, but it's really, from my standpoint, you need to understand is how does biochar function? And then it's a tool, but you just need to use that tool in the appropriate place. There are times when I will recommend biochar, but it's not a panacea. It's not an end all be all kind of thing. It is a specific use case where it's like, this is going to solve my problem because it's available, it's cheap, or whatever else. So it is a tool, but not something that I reach to very frequently at all.
And some people like use biochar like, hey, let's use this to like basically as a giant filter for toxic materials,
Sure.
like cleaning up waterways. Like
Great.
Great.
even if the context isn't great, like I mean, there's so many contexts where biochar is fantastic for soils. Like
Yep.
I read there's books about it, but also it's like there's so many things it can do. It's just learning your context for what you can and can't do with it. And of course, no one's going to chuck biochar on the soil like just blanket. Like that's like just definitely not a good idea for sure.
It is.
Yeah.
There's a lot of
It,
good
it,
tools available, and we do not have to use them all at once. Just because
Yeah.
someone is like, man, this is awesome, you can always say, nope. I mean, Carl brought up, it's like, yeah, if you were using it to like, say you had stinky anaerobic compost, I bet that would be an awesome use for it. Our compost has never smelled bad once. Our
Right.
manure scent doesn't even come through on day one. So it's like, for us, it doesn't necessarily make sense. Where for others, it could be their golden ticket to winning composting. You know what I mean? Um, Go ahead, Casey. You were
Yeah.
gonna say
I'm
Casey's
something.
good.
chomping.
I'm good.
No, come on. Come on.
I'm
Eat
good.
today. You
We'll
easy.
save this. We can save it for the ultimate, like the
No,
ultimate
I want to hear
biochar
it.
session.
I
But
want to
yeah,
hear it from Casey.
Casey's always got a hot, controversial take.
No, I don't know. It's just I like it's like even like with what Carl said, it's like it speeds up the composting process by 20%. And it's like I don't really understand how that could be true. It's not something that breaks down. It's a stable carbon source. It is not a food resource. Yes, it does, it does take things from the soil, like it can suck up soluble nutrients and things like that. Making it like a house, like the idea of that it is a home is like fungi don't go home after a long day's work and have a fungal beer at the end of the day. You know what I mean? They're going to live where they eat. And so yes, in some regards, like if that biochar is packed full of nutrients and something like that, fungi might grow over to it and eat some of that nutrients that's on there, but it is not a home for fungi. In my, visualization of this, and how is that not specifically in a compost pile? Like, how is a wood chip full of nutrients already? It does not have to absorb any from the environment. It's already present in the structure of itself. It is food. I cannot see how taking that, burning it, and literally releasing all of the carbon monoxide, all of the other gases that it claims to also mitigate when you put it in the compost pile. You already had to create those gases before you could mitigate them. So is it a net zero? I don't know. And so in that regard, like how is a wood chip not better? It is better. It has to be better. I can't see the argument around that.
We all adore your love for wood chips over biochar. It's one of my favorite topics. As soon as someone says biochar, I'm like, yes. Yes. Casey's gonna jump on his
Well,
biochar.
it's just like if you logically
So
think about
fun
it, how can
topic.
it be better? It cannot be
Yeah.
better than a wood chip because first of all, the amount of energy it took to then create that wood chip, right? That's already an energy loss, right? You had to use fuel, you had to use manual labor. Now taking that wood chip again, burning it, now you've again used manual labor. You've now wasted any of the nutrients that tree had acquired. And then you go and put it back into your compost. And that's a third time. You're adding an extra process to something that in this regard, I do believe biochar has function. Don't get me wrong on that aspect of it. I do believe it has function, but I don't see how it's like this end all be all of the greatest thing that's ever happened to soil. I just don't see it.
Everyone's loving. You're getting great. You're getting great response in the comments. They're, preach, preach. David says, I don't want to pay the extra shipping on biochar in your compost.
Yeah, right, for sure.
It's lighter than compost, David.
It's actually going to be lighter. You're going to get
That
less
might be a way
compost
for
per
us to
yard.
save you some money and not have to use as much of our compost in the product. Wait a minute. Never mind.
There's no doubt this is going to be on our podcast list of things to talk about podcast.
Oh my
Oh, I
God.
know,
Not
I know.
about
And
biochar.
we've got some people that are like they're the biochar gurus, and I'm so excited to just like get on and talk to them because as I've been, we got Casey on one side and you've got everybody else on the other. And I try to like figure out what's real. And a lot of times people are pretty aggressive. If I try to ask questions in biochar groups, they're just like, don't mess with my biochar. But I have found that there are a lot of like some scientific articles and some folks out there that are really kind to sit. And so I'm learning. Casey hasn't listened so much yet, but that's okay. Like we're all in different places, and that's great.
And thank you,
Great,
Frank, for
great
saying
topic.
biochar. It isn't. There's nothing bio about biochar.
It's
It
char.
is very, very true.
Yes. Well, here's a quick. Oh, there's so many. I see two hands raised. We should totally get to the live questions. But a quick one from Dominic. Your question's been sitting there forever. It's just about water, dechlorinating. Do you use chlorinated water for irrigation? If so, if there's a problem for biology, and how do you dechlorinate? Like we kind of went over this, but just as a quick reframe, how you dechlorinate water.
Well, if it's chlorine in particular, you can off gas it. That's probably the cheapest way, which means you put it into a barrel and you let it sit for 24 hours. The chlorine will off gas, and there you go, you're done. But if it's chloramine, it doesn't off gas, which means you have to treat your water. You have to do something to be able to bind or tie up. Humic acid is probably the most typical way to do it. You can add a couple drops of humic acid in a large volume of water, and boom, it's tied up most of the chloramine that's in there. For ease of use, some of us, I use on mine, I have on my host bibs, I have these little carbon filters. You can find them a lot for like RVs. They're maybe a foot long round tube that you screw into the garden hose between the faucet and the hose itself. And it will filter out 99% of the chloramine or chlorine that's in their water. And it works great.
What's it called? Boogie
Boogie Blue is the one of the
Boogie
main
Blue.
products.
The guy that owns that company too is like so freaking sweet. Like he's like the nicest guy. If you guys
Right.
order a Boogie Blue filter, like call the company and talk to the guy. So he loves microbes, he loves soil. He usually sends like free gifts. He's so great. The
Love you,
Boogie
Boogie Blue.
Plus actually goes farther than the regular Boogie Blue too.
Oh, it does. Okay.
An
Yeah.
extra $10 and it does like double the amount of water.
Okay. Nice.
Well, okay, it's live question time. Let's see who's still got their hand up. Well,
I think
folks
Michael's hand's
lower
still
the,
raised.
well, yeah, let's go. We'll do Michael, then Laurel.
I think Michael's is still raised from earlier.
Yeah. Oh, did
Yeah,
you
yeah, yeah.
re-raise your hand or did your hand?
I don't think so. I
I
think
thought
you can skip
I
the
thought I
Laurel.
lowered his hand and then he re-raised it.
That's
but-
all right.
All right. Well, I'll lower his hand, but if he raises it one more time, I know he wants to ask a question.
There's a cool biochar comment here. Donald was like, I haven't
Laurel-
experimented yet. Oh,
Oh, Laurel
Laurel's
has
Hey,
here.
Laurel.
Oh,
Hey,
Yeah,
Laurel.
sorry, Laurel.
So I just want to get on the biochar rant. Okay. I've taken Kelpie's course and it's not that I'm changing my mind about it, but there are so many factors. So right now I'm trying to, because I've gone from a closed system because it was just too polluting where I am. We just couldn't deal with, I don't know what we were doing wrong, but creating a lot of smoke. So I'm using rings similar to Kelpie's and now working on trying to get my husband to make me a probe that I can put into the center so that I can use an infrared thermometer to measure, because apparently you can't use it in open flame. So, I mean, that's the biggest factor, right? You have to know exactly what temperature you're producing it. you have to know the pH. So I know I'm in that higher range because it is 300 degrees Celsius up to close to 1,000 degrees Celsius. And the lower range, they say, is food. The higher range, it's housing. So what I'm doing, because I don't have accurate temperatures and I have an idea, I'm looking at the pH and how that affects things. So they've talked about it only using, it's mainly for acidic soil. And I was thinking, no, we should be able to use it in any soil. So I'm playing with adjusting it. But just as an example, I took some soil from a farm that I do experiments at. His soil was a pH of 6. My pH of my biochar was 10. And overnight, it changed that soil to a pH of 8. So I'm looking at it from that way. If you need to be adjusting your pH, that could be a way of using it.
Yeah, and that you described exactly as you thought of it as a tool. You found the appropriate solution, said, I have a pH problem. I want to use biochar to fix that pH. And that is a tool you can do for a quick fix kind of thing. And the way I would follow that up would say is if I needed to quickly fix a pH, I could use something like a biochar, but I also have to look long term. Why is my pH off? And how do I remediate for the long haul? And then you follow that up with maybe the microbial approach is saying, hey, look, how can I get the microbes in there to rebalance that pH to get it, to the balance that I want to be in? But I love it, Laurel. You used it as a tool. You was like, I thought it through. I knew it could do these things, and that's how I wanted to be able to use that.
Yeah, and initially I got onto it because I'm in a remote area where everybody has their big burn piles every spring and all winter, plus with the logging. So I was looking at as a way to be more environmental with dealing with all the windfall. And I make my own, I don't do my own compost. I fail at compost, but now you guys and people within my own two communities are changing or remotivating me, but I also do my own biofertilizers. So we do use that up at the farm. We use that for changing with the biochar, because we don't want his pH at 8 anyways. That's when we start to have aphid problems. Sure. It was great that the soil over the 2 years of doing, or even especially last year at the microbes we're using, has finally adjusted. And that's in a greenhouse, which is always kind of hard to deal with. So anyways, that's all I wanted to say. Thank you.
That's great.
Thanks, Laurel.
Thank you, Laurel.
And Laura, one thing I just add to the end of that is now that you use that and you went too far in the pH, now you know how to adjust down, right? It was probably, if you were trying to use it as a tool, just use less quantity and figure out what that ratio is.
Do it in the greenhouse. I just came home with soil and played with it here. So
nice.
Yeah.
Nice.
Thanks, Laurel.
And Nisha, no reason to apologize. This is the wildness that we love at Compost Academy. Getting on to topics of the best tools, how we use them, whether or not we like them. We're always in a state of back and forth and debate and conversation about many different things. So biochar is one that's always on the topic. Yeah. Raleigh asked us to, let's get in here. Dominique has some questions.
Well, that's
I'm answering one of
Dominique's.
Dominique's.
Yeah,
I answer one
from like he's asking about
You're
soil sensors. But meanwhile, Michael's back on.
Oh, Michael's back.
Yeah, I just missed the unmute last time, so I had. I'm making it very complex for what should be simple, but I wanted to circle back to Brian's comment on heavy metals. I'm a retired doc with a focus on environmental medicine, and we're seeing obviously more and more chronic illness, and a lot of that is we live in a toxic environment. And of a lot of things we're exposed to, oftentimes heavy metals are often underdiagnosed, if not ever diagnosed. And I want to circle back to the soil. Our internal biochemistry and metabolic rate is inhibited immensely by heavy metals. Our vital gut ecology is very similar to the soil ecology. And I had a biodynamic farm while I was practicing, and it was the regenerative agriculture taught me more about medicine than medical school did, to be honest with you. Mm-hmm. So what I would suggest to you is if you're going to do a big project that you preemptively test the soils for heavy metals. because that will impede the concentrations of fungi. And I don't know if you know Paul Stamets, who's kind of
Sure.
mycelium running.
Yeah,
He
yeah.
did a great study on toxic dump sites, federal toxic dump sites, and how to remediate. And he did different compost piles with different species of mushrooms. And oyster mushrooms are one of the most beneficial to chelate those heavy metals.
Well, yeah.
But
Yeah.
it also begs the question, okay, the mushrooms have chelated the metals, are concentrated in heavy metals. What do you do with that? You don't want to recycle it back.
You have
Correct.
to remove it.
And in medicine, when we chelate heavy metals out, we often do it through oral chelators. It's dumped in the urine, so you don't want to pee that out and have it come back into the water and the soil.
Right.
So we got to isolate that and recycle that.
Yeah.
That would be a big business. So I don't want to go on and waste your time, but I think preemptively testing for heavy metals goes a long way for that higher fungal ratio you want to see in mature standing trees or
You bet.
plants, whatever.
Well, and I think, microbes are an extraordinarily valuable tool in ecosystem restoration projects where we have these toxic levels of heavy metals. And I think the work that Paul's doing, there's a whole bunch of other mycologists that are just doing fantastic work with fungi because fungi are just amazing organisms and able to chelate, to change, break down complex chemical compounds into, compounds that are no longer harmful or have a reactionary with the surrounding ecosystem. So I think there's a huge amount of work and study that needs to be done in this space. And I just applaud people like Paul and the work that he's doing in that space. But thank you for bringing that up, Mike.
Hey,
Yeah,
one quick thing back to the transfers that you were
Mhm.
talking about.
Mhm.
Could that be some of the deep fungal networks, the hyphae networks, that are connected with the other species from the treatment plot to the test plot? Not
I
only superficial, but
I think for sure there's probably a part of that equation which could be that some of that transfer through some of these areas. There are some parking lot areas that are pretty isolated and far apart. But I think probably the majority of the transference, because of how quickly it was moving in so many of those species, that it was probably through the taxicabbing was the primary method. But I would not discount that underneath the soil, as roots grow, and as those roots grow, the microbes will follow. And are their ability to transfer and where roots do touch underneath the ground? By all means, I think transference can happen there as well.
thanks.
Yeah.
awesome.
Thanks a lot. I really appreciated this. It's been really informative, and I'll be back.
Great.
got it,
Oh,
Mike.
Great.
Thanks for
awesome, Michael.
joining.
Good to have you.
Oh, also, I mean, heavy metal is such a huge topic. I know a lot of folks who came to, Camp Callus were dealing with after the LA, like the enormous LA wildfires. How do they tie up this like sudden, huge downpour of heavy metals? Like, because after a giant fire, there usually comes a giant flood not soon after. So it's like, how do you quickly tie up those metals? It's a
Well,
huge
and let's
thing.
talk about Altadena. They decided to when our compost lot burned down, they came and scraped like how deep, Casey? It was feet.
Yeah. Well, I
they
think it was like 8 to 12 inches or
The
something.
EPA came and scraped, and in Altadena they decided to stop scraping so much because they couldn't get all
They
the
had nowhere
waste
to put
to
it.
dumps.
Yeah.
Yeah. So there's a bunch of our, colleagues and friends down there working on bioremediation using microbes, extracts,
Yeah,
and native plants.
berms.
Yeah,
Like
And
check
they're
dam
removing
berms.
that biomass, and they're showing a reduction in the heavy metals in that topsoil that was recently impacted down below the EPA's regulation. So they're making moves fast with microbes in Altadena right now.
Yeah.
It's a space to watch if
Yeah.
you're into ecosystem restoration post-fire.
Michael brought up a great point, right? It's like, yeah, you can tie up these heavy metals into the bodies and things like that of like the fungal, of the fungal bodies of oyster mushrooms, or if you're using like a biochar filter, like it will pull in some of those heavy metals. But yeah, you have to take it out of there and remove it because it's not going anywhere. Once that fungi dies, boom, it's right back into the soil. Or if you leave a bag of, whatever sock compost filter or biochar filter, something like that, it's going to stay in there until it hits a saturation point, and then it's just going to start passing through it and then even start releasing it in the future when it exchanges it for different elements. So yeah, The tough part of remediation is you still got to pull it out of there when you're done.
Well, and setting
Charles
up all
says, what
these
about
filter
Roundup as a
berms.
chelator?
Yeah. Dicamba. Let's use more dicamba. Woo. All right. We got, I think like this, let's do 3 remaining questions. We probably answer these fast. That's probably a great place to end this. I guess we'll do Carl, Dominique, then Joseph. It seems like so quick answer for Dominique. Which tool or sensors do you use to measure the quantity of water used? Or I
Brian.
guess how do you guys measure quantity? Like how
Oh,
do you,
measuring. How do you measure the water going into
Yeah.
the?
Yeah, so how do we measure the quantity of water being used is through the smart controller itself. And so they have meters that are built into the valves that are able to determine the actual flow of water that goes through there. And it's great because it reports it right back out. And so you just have this running tab that just constantly comes back to you and tells you exactly how much water you use. And simply for us, we just took the control plots and the treatment plots, and then we just looked at the values of water being used, and then we're able to make those the value, how much water we saved in that sense. And in the smart controller, we are also able to set the percentage difference, saying between these valves, I want to have this percentage difference in as far as the amount of water being delivered.
Cool. All right, Carl, any thoughts about crop biodiversity to maintain soil balances?
Oh yeah, I got so much to say on this.
Keep it short,
Carl, we
Brian.
only have 2 minutes. You're going to unleash the dragon in Brian.
Biodiversity, diversity of plants usually equals diversity in microbial communities, which usually means more stable, resilient ecosystems. That's why monocrops are always a very difficult thing. In agriculture, we deal with this all the time because a lot of farmers monocrop. Anytime we can add in additional diversity of species, we see improvements in usually crop production and the overall structure of the soil and so forth. I'll use an example. When we get into orchard environments, we usually want a diverse understory underneath that orchard environment or vineyard environment so that we, again, really broaden the amount of microbial players that are in that particular soil system. So I love that. Diversity to me is equal to good ecosystems, good resilience. I'm sure Keith and Casey have the same thoughts or something to add to that.
I do. I mean, I'm thinking compost. I'm like diversity of inputs in, but same. I mean, my garden constantly trying to diversify everything in there with our clients over and over again. Like we've seen the benefits of turning a monoculture into, I mean, if you put understory plants, you can just, it's no longer a monoculture anymore. It's all of a sudden have partner plants. So in the orchards, especially,
Yeah.
we see excellent movement using the cover crops in the almond system.
Oh,
So
yeah.
it's like, yeah. Of
Hey,
course
I
they-
realized one thing we did not do. We did not drop your guys' link for Catalyst Bioamendments or Soil Matters. Ding-a-ling. So for people to
If you-
know,
We're here to have fun.
their consulting company is Soil Matters. If you actually like want to help have them come out to consult on your land, on your projects, on your composting, they're Brian, Keish, and Casey work together on Soil Matters. So just visit soilmatters2.us. I just put that in chat box, of course.
Soil matters to us.
Yeah, to us.
Yeah.
To us. And then we have catalystbioamendments.com, which of course, like you can't not get some compost after this. Come on. Like I was so lucky after that big fire, like they sent me like they had to get rid of this total compost that I took in, and it was like it maintained amazing quality and moisture for like the entirety of years that I used it. Like one bucket I just left in the garage, forgot about it, let it sit for 9 months, and I came back and there were still worms in it. And it's just like every time I checked it under a microscope, it was just filled with so much fungi, so many. Like I feel like I almost always saw nematodes in it. It's like the best compost I've ever seen. It's incredible.
Raleigh, you actually, the story on that was like, and it looked like we were cheating because the
Yeah.
fire happened and we needed to generate income and interest so that people would help us not go away forever.
Mhm.
And we did a giveaway for a full yard
Yeah.
of compost. And you literally, like you
Won the random
commented or
drawing.
whatever. And I wrote down all the names and I put them in the hat and I pulled it and I drew yours first. And I was like, oh,
Yeah, it's
that
like,
really looks like we
cheated.
cheated.
Yeah,
But
we really
then
cheated.
throwing his name out would be actually cheating. I thought it was so crazy. You won that competition. It was
Yeah.
perfect.
Well, we enjoyed it highly. We resurrected a bunch of trees with it. It was great. All
Awesome.
right. So I guess last question, Joseph, do you ever use auxiliary tests to demonstrate the benefits of biology, i.e. compaction, bricks, electrical conductivity?
You want me to take it?
Literally has a bricks meter
Oh,
in his pocket right
data.
now. I
He's
do
got his
not
bricks meter
lie.
in his
Boop.
pocket
Yeah.
About to
protector.
whip it out.
Actually, it was so funny. I went to go reach for it because I have it right here, but I
You
forgot.
needed to hold it.
It's upstairs actually because I would brick something recently.
You were bricksing your fruit.
He's red in the face because that's how much he adores the bricks. Go ahead,
Oh my
Brian.
gosh, yes.
We don't deserve the
I have
time.
a bricks addiction, it's for sure.
Bricks
And
addiction.
yeah, bricks is a tool and it's a controversial tool because it's measuring something and a lot of people will try to transfer the results into something else, which means if I'm seeing high sugars, does that mean that the plant was very healthy and is it nutrient dense and all those kind of good things? And there is a correlation for sure, but it's not absolute. It doesn't mean if I have a high bricks reading that it's highly nutrient dense either. So I just want to give that word of warning. But for me, like when in our homestead, when my wife and I were really, making our homestead sing and we were consuming a lot of the food that we ate, I was brixing everything just to see how much more the plants were producing those sugars, and the flavor and the taste correlated with the higher brix levels. I mean, it just really does. So yes, brix is a tool that you can use for sure. And other tests that are out there, compaction is another tool we use all the time. Compacted soils tells us a lot about the microbial communities and the structure that's there. So a penetrometer is a tool that we use, and for those of you that are growers, it's a tool I would invest in because it will help map over time, how well the microbial community is performing. I'll give one cool example. Almond farmer, a client of ours. He's a skeptic on all this stuff, and he was a hard convert to pull around. And after 2 years of working with them, we were out in his orchard, and we had cover cropped the middles, and he still had bare underneath his trees because at almonds, it's a particular thing about harvesting. I won't get into it right now, but he asked this question. We were out there with the penetrometer, and he goes, "So, Brian, because you planted the cover crops and you say the microbial is better in the middles, if I was to take this penetrometer and push it down the soil, it's not going to be nearly as compacted as it would be underneath the trees where there's bare soils." And I just handed him my penetrometer and said, "There you go, Mike, test it, see for yourself." And he walked over to the underneath the trees and he pushed in the soil. He's a big guy like me, could barely get the penetrometer in there. Compaction was high and heavy. So he walked over with a big smile on his face and put it into the cover crops, and it just sunk right down the ground. He pulled out of the ground, handed back the penetrometer, said, "Done. I believe. That's all I need to see." And I was like, "Great, Mike."
I love stories about proving Mike wrong. He's kind of curmudgeonly as a farmer. He's a little grumpy. And when we first met him, it was years. We've been working with Mike for a long time. He was one of our first large scale clients, and he was so rude. He came to our compost lot and he's like $750 a yard. You're never going to see my face again unless it's this compost does something magical. Like he called us last week. We talk to him all the time. He's one of our biggest clients. We see him monthly all summer, and he's built an entire extraction building for our compost. So Mike was one of those people that started out like, no.
No.
And slowly over time, like he can eloquently speak about microorganisms and their value now. Like he's a microbe farmer. He's really changed his tune over the years. And that's my favorite stories. He's our grumpiest client.
Totally. Yeah.
Keisha, I believe in magic now.
Yeah. Almost. It's more like, Keisha, can you change your inputs to make a compost that's precisely fit for my almonds? He just wants me to make compost for him only.
Yeah.
And don't even worry about any
Exclusive.
other crops. Almonds. Amen.
Almonds.
Almonds.
Salmon.
Yep.
All right.
All right,
I think that's
everybody.
it.
What a wonderful session. We were going to go an hour and a half. We did almost 2.5 hours. Whoa.
And there's 44 of you still with
Still
us.
with us.
Yeah,
You are
you're the crazy
true
ones.
Yeah.
Thick
We're not crazy.
believers.
You are.
You are.
Well, we appreciate everybody sticking around. It's been such a joy having you guys here. Hopefully and keep an eye on your inbox. We got some really fun stuff dropping. We're gonna have the White Sides video coming soon. Everybody, you're gonna get the offer again one more time about the the upcoming soul mentorship program. So you want to hop in if you want to get that discount. But we love having you guys here and can't wait to see you again soon. Oh, and replays coming to your inbox too. All right. Ciao, everybody. Bye.
See you all. Bye.